So I'm going to go over this quiz with you. This is on averages, okay? So just to review averages, we find them by adding everything up. So let's pretend we have x plus y plus z. We divide it by how many there are, and this gives me the average. You got to remember this equation here because we're going to use this later on when we're dealing with an unknown and we set it up like an algebra equation, okay? So now that we've covered how to find averages, let's look at how to do these questions. So it says, number 1, the temperature in a town is recorded as follows: 36 degrees at 9 a.m., 44 degrees at 12 p.m., 43 degrees at 3 p.m., and 42 degrees at 6 p.m., and 35 degrees at 9 p.m. What is the average temperature recorded in the day? So here we're going to add up all the numbers and we're going to divide by however many there are. So we have 36, 44, 43, 42, 35. So one more time, 36, 44, 43, 42, 35. Because these are the temperatures. We don't do anything with the times. So here we go. 6 plus 4 is 10. Well, that was weird. 6 plus 4 is 10. 10 plus 3 is 13. 13 plus 2 is 15. And 15 plus 5 is 20. So I put a 0, carry the 2. 2 plus 3 is 5. 5 plus 4 is 9. 9 plus 4 is 13. 13 plus 4 is 17. And 17 plus 3 is 20. So now we're going to divide by however many there are. There are 1, 2, 3, 4, 5 temperatures. So 200 divided by 5. 5 goes into 20 4 times. 5 times 4 is 20. 20 minus 20 is 0. I still have to bring down a 0. So 5 goes into 0. 0 times 0. And now we're done. So my average is 40 degrees. Pretty straightforward, right? Let's take a look at number 2. It says, Samantha ran 4 miles on Monday, 3 miles on Tuesday, 5 miles on Wednesday, and she rested on Thursday. What is the average number of miles she ran over the 4 days? So 4 miles on Monday, 3 miles on Tuesday, 5 miles on Wednesday. She rested on Thursday, which means 0 miles on Thursday. The average over the 4 days. So we have 4 plus 3 plus 5 plus 0. And we're going to divide it by 4, and that's going to give us our average. Okay? 4 plus 3 is 7. 7 plus 5 is 12. 12 plus 0 is just 12. 12 divided by 4 is 3 miles. Okay, I hope you got that. I'm going to move on to the next one. Number 3, it says, Aaron played video games for 2 hours on Monday, 1 hour on Tuesday, 1 hour on Thursday, 30 minutes on Friday, and 2 hours and 30 minutes on Saturday. What is the average time Aaron spends playing video games per day in the entire week? 7 days. So that means there's a Sunday here that they didn't tell us about. So let's do Monday, 2. Tuesday, 1. Wednesday, didn't give me any, so 0. Thursday, 1. 30 minutes on Friday, so I'm going to do 0.5 because that's half an hour. And 2 hours and 30 minutes on Saturday, so 2.5. And Sunday, 0. So I should have 1, 2, 3, 4, 5, 6, 7. I'm going to divide this whole thing by 7. 2 plus 1 is 3, plus 1 is 4, plus 0.5, plus 2.5. Let's do 0.5 plus 2.5. That gives me 0, carry the 1, 3. Plus 4, 7. Divided by 7, 1 hour. Okay, I hope you got that. That one might have been a little more confusing because of the decimals. Okay, when you're ready, number 4. It says, Brenda swam 2 miles on Monday, 2.5 miles on Tuesday, 1.5 miles on Wednesday, and she rested on Thursday. What is the average number of miles she swam over the 4 days? So 2 miles plus, actually, I'm going to set it up in another way. 2 miles plus 2.5 on Tuesday, 1.5 on Wednesday, and 0 on Thursday. And that way it's easier to add up our decimals, okay? So 5 plus 5 is 10, carry the 1. 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 1 is 6. So 6. Now, what are we going to divide this by? 4 days. So 6 divided by 4. 4 goes into 6 one time. 4 times 1 is 4. 6 minus 4 is 2. Because we have a number left over, we're going to add a decimal point. We're going to bring down that 0. 4 goes into 20 5 times. So this is 1.5. 4 times 5 is 20. 20 minus 20 is 0. There's nothing left over and there's nothing to bring down. So my answer is 1.5 miles. Okay? Okay. Next question. It says, Calvin practiced the violin for 2 hours on Monday, an hour and a half on Tuesday, 1 hour on Wednesday, 60 minutes on Friday, and 1 hour and 30 minutes on Saturday. What is the average time Calvin spends practicing violin per day in the entire week, which is 7 days? So this right here tells us that we're going to divide it by 7. So here, there's something we have to be careful with. It has hours and minutes, so we have to put everything in hours. For example, here 60 minutes, we know is 1 hour. Okay? So let's go one by one. Monday, 2 hours. Tuesday, an hour and a half, which I know is 1.5. Wednesday, 1 hour. Thursday, oh, it doesn't have anything, so 0. Friday, 60 minutes, which is just 1 hour. Saturday, 1 hour and 30 minutes, which is an hour and a half, or 1.5. And Sunday, it doesn't mention it, so it's 0. So now that we've done that, let's add decimals and zeros. And let's add stuff up. 5 plus 5 is 10, carry the 1. 1 plus 2 is 3, plus 1, 4, 5, 6, 7. I'm going to divide it by 7, because that's how many days there are. And 7 divided by 7 is 1 hour. Okay? These are pretty easy. I hope you're getting them. Remember, if you have a question, you can leave a comment below. Number 6 says, Charlie scored 66 on his first quiz and 62 on his second quiz. What must he score on his third quiz in order to get an average of 65 on all 3 of his quizzes? Okay, so this one, remember I told you, let's remember that equation for averages. We're going to use it now. So we know that to find an average, we have to add up everything. So 66 plus 62 plus, does it tell us what he scores on his third quiz? No, it's an unknown, which we always write as x. And then to find the average, we're going to divide by however many there are, which are 3. And we know that this will give us an average of 65. The question is asking us what he must score. So if we put an x there, it's going to help us solve it. So now let's do 66 plus 62. So we can simplify that. That's 828. So 128 plus x divided by 3 is equal to 65. Now, I don't like this divided by 3 here. I don't like this fraction. So I'm going to do the opposite of it to get rid of it. So I'm going to do multiplied by 3 and multiplied by 3. When I do that, that cancels out there. And now I have 128 plus x and whatever 65 times 3 is. So let's solve that over here real quick. 3 times 5 is 15, carry the 1. 3 times 6 is 18, plus 1 is 19, so 195. Okay, so far so good. Now, right now we see that x and we have 128 added to it. To be able to isolate the x, we have to do the opposite. So if something is added to it, we have to do the opposite. We have to subtract from it. Minus 128. Whatever we do to one side of the equal sign, we always have to do to the other side of the equal sign. So this cancels out because it equals 0. I'm left with only x here. 15 minus 8 is 7, 8 minus 2 is 6, 1 minus 1 is 0, so my answer is 67. So this is some light algebra, but we still got it. These are more challenging questions. Let's go ahead and look at number 7. It says, in a store, 2 clerks are paid $250 a week, 3 clerks are paid $300 a week, and 3 clerks are paid $200 per week. What is the average salary paid to all 8 clerks in the store? So, we have to find the salary of all 8 clerks. 2 of them are $250. 3 of them are $300. And 3 of them are $200. So let me make sure I got this right. 250, 2. 300, 3 clerks. And 200 are 3 clerks. Okay? 0. 5 plus 5 is 10. Carry the 1. 2, 4, 6, 8, 10. So I'm doing 2, 4, 6, 8, 10. Plus 1, 11. Plus 3, 14. Plus 3, 17. Plus 3, 20. Okay, so 2,000. Now we're going to divide this by 8 because that's how many clerks there are. 8 goes into 20. 2 times. 8 times 2 is 16. 20 minus 16 is 4. I bring down a 0. 8 goes into 40 5 times. 8 times 5 is 40. 40 minus 40 is 0. Bring down the 0. 8 goes into 0 0 times. 0 times 8 is 0. 0 minus 0 is 0. So my answer is $250. And there we go. Okay, let's keep going. It says, the temperature in a town was recorded as follows. -4 degrees at 9 a.m., 0 degrees at 12 p.m., 3 degrees at 3 p.m., 2 degrees at 6 p.m., and -1 degrees at 9 p.m. What is the average temperature recorded in a day? So -4 plus 0 plus 3 plus 2, -1. -4 plus 3 is -1. -1 plus 2 is +1. +1 minus 1 is 0. And if I divide this by 5, 0 divided by any number is just 0 degrees. And that's my answer. If you struggle with positive and negative numbers, I encourage you to go back and look at the section on positive and negative numbers. Okay? Super important. Okay, so let's do number 9. It says, a competitive jumper records his jumps on a given day. He records 2 jumps that were 38 inches. So 38 plus, I don't know why I did this, 38 plus 38. 1 jump that is 39 inches, and 1 jump that was 4 feet. What is his average jumping distance for that day? So this 4 feet, this 8 is bothering me, let me fix it. This 4 feet doesn't match because these are in inches. Okay, so we have to turn 4 feet into inches. Well, we're going to multiply by 12. 12 times 4 is 48. So that's 48 inches. So now I'm going to add them up because I want to find the average. So I have to add them up and then divide by the number that there are. So 8 plus 8 is 16. 16 plus 9 is 25. And 25 plus 8 is 33. So carry the 3. 1, 2, 3, 4 threes. So that's 12 plus 4 is 16. One more time. 3 plus 3, 6 plus 3, 9 plus 3, 12 plus 4, 16. So now I'm going to do 163 divided by 4. 4 goes into 16 4 times. 4 times 4 is 16. Bring down the 3. 4 goes into 3 0 times. I add a decimal. Bring down the 0. 4 goes into 30 7 times. 4 times 7 is 28. Let me scroll a little bit. 30 minus 28 is 2. Add another 0 because we still have numbers left over. 4 goes into 20 5 times. 4 times 5 is 20. 20 minus 20 is 0. So my answer is 40.75. And there it is. Okay, I hope you got that. I'm going to move on. It says, a sprinter ran the 100-yard dash 4 times. His average time was 36.2 seconds. What does his time have to be on his 5th run in order to reduce his average time to 36 seconds? Okay, so he ran 4 times. His average was 36.2 seconds. So these 4 times x plus y plus z plus a divided by 4 gives us 36.2. Okay, what does his time have to be on his 5th run? So we're going to add a 5th run. X plus y plus z plus a plus b, that's our 5th run, divided by 5 equals 36. Okay, what in the world is this number right here? Well, if we multiply by 4 up here, we solve for this. We'll find out that x plus y plus z plus a is equal to 36.2 times 4. 8, 24, carry the 2, 12 plus 2, 14. There's one number behind the decimal point, there's one number behind the decimal point in my answer. So that's what that means. So I can replace this with 144.8. That's exactly what I'm going to do. Okay, so now that I've done that, I want to solve for b. So I'm going to multiply by 5, and whatever I do to one side, I do to the other. I get 144.8 plus b is equal to, what's 36 times 5? 5 times 6 is 30, carry the 3. 5 times 3 is 18, plus 3 is 21. Sorry, let's do that again. 5 times 6 is 30. Put a 0, carry the 3. 5 times 3 is 15, plus 3 is 18. So 180. Now I'm going to subtract 144.8 from each side. I have to add decimal 1 is 0. This leaves me with b equals. Oh, I gotta borrow here. 10 minus 8 is 2, decimal point lines up. 9 minus 4 is 5, 7 minus 4 is 3. So my fifth time, or the sprinter's fifth time, is 35.2 seconds. So this question was a little more challenging. Feel free to go back and watch the explanation again, okay? But what I had to do was I had to figure out what the sum of the original 4 were to be able to plug it into my new averages equation, okay? When you're ready, let's look at number 11. Number 11 says, the average weight of 3 patients in a doctor's office is 156 pounds. If another patient's weight is taken and the new average is 160 pounds, what is the weight of the new patient? Okay, so we have 3 patients, A plus B plus C. And their average weight, which means when we divide all of their weights added up by 3, we get 156 pounds. But let's say we get a 4th patient, this guy right here, or this girl right here, okay? And when we add this person, and we divide by 4, which is finding the average, we get a new average of 160. So this is what the question is asking us. 4, what is the weight of the new patient? So how do we do this? How do we find out this number right here? We take this equation. We multiply by 3 because we want to get the A plus B plus C by itself. And whatever I do to one side of the equal sign, I have to do to the other. This cancels out, and 156 times 3, 3 times 6 is 18, carry the 1. 3 times 5 is 15 plus 1 is 16, carry the 1. And 3 times 1 is 3 plus 1 is 4. So A plus B plus C equals 468. Well, guess what? I can replace this with 468. So now I have 468 plus D divided by 4 equals 160. So now I'm going to multiply by 4 on each side. And when I do that, I get 468 plus D is equal to 160 times 4. 4 times 0 is 0. 4 times 6 is 24, put a 4, carry the 2. 4 times 1 is 4 plus 2 is 6. So I get 640. Now I'm going to subtract by 468 because I want to get the D by itself. So D is equal to borrow here, 10 minus 8 is 2. I can't do 3 minus 6, so I borrow here also. 13 minus 6 is 7, and 5 minus 4 is 172. So the new patient's weight is 172 pounds. Okay, I hope you got it. When you're ready, let's move on to the next one. Number 12, it says, a candle store sold 222 candles 1 week, 325 candles the second week, and 185 candles the third week. What is the average weekly sale of the candles for the store? So here, this is straightforward. It's just adding these 3 weeks up, 325, 185, and then dividing it by the 3 weeks, okay? So 2 plus 5, 7, plus 5, 12, carry the 1. 1 plus 2, 3. 3 plus 2, 5. 5 plus 8, 13, carry the 1. 1 plus 2 is 3. 3 plus 3 is 6. And 6 plus 1 is 7. So we're going to do 732 divided by 3. 3 goes into 7 2 times. 3 times 2 is 6. 7 minus 6 is 1. I'm going to bring down the 3. 3 goes into 13 4 times. 3 times 4 is 12. 13 minus 12 is 1. And I bring down the 2. 3 goes into 12 4 times. 3 times 4 is 12. 12 minus 12 is 0. And there's nothing else to bring down. So my answer is 244 candles. And there it is. Awesome. That one was straightforward. No algebra with that one. Let's look at number 13. It says, a seamstress cuts different sizes of fabric. She cuts 2 fabrics that are 18 inches long, 1 fabric that is 8 inches long, and another fabric that is 2 feet long. Okay, so I see inches, feet. What is the average length of the fabrics that she cut? So let's just add stuff up. 2 of them are 18 inches, so 18, 18. One of them is 8, and one of them is 2 feet long. Remember, we have 2 feet, we're going to multiply it by 12, and that gives us inches. 24. So we add all this up. 8 plus 8 is 16, plus 8 is 24. 24 plus 4 is 28. So put in 8, carry the 2. 2 plus 1 is 3, 3 plus 1 is 4, 4 plus 2 is 6. Now I'm going to divide by however many there are, and there are 4. So 4 goes into 6 one time. 4 times 1 is 4, 6 minus 4 is 2. Bring down the 8. 4 goes into 28 7 times. 4 times 7 is 28. 28 minus 28 is 0. So my answer is 17 inches. Okay, I hope you got that. When you're ready, let's move on to number 14. Okay, so this looks like one of those algebra ones again. If you want to hit pause and give this one a try before I go over it, I encourage you to do it now because these algebra ones are pretty challenging. When you're ready, I'll give you the explanation now. It says, a sprinter ran the 100-yard dash 4 times. His average was 28.4 seconds. What does his time have to be on his 5th run in order to reduce his average time to 28 seconds? So he's going to have the first 4 times. A plus B plus C plus D divided by 4 gives him 28.4 seconds. Now we're looking at a second scenario. A plus B plus C plus D plus a 5th run, E, divided by 5, and this one has to be 28 seconds. So what we want to do is we want to get rid of so many unknowns, and we're going to find out what A plus B plus C plus D is equal to. So we have it up here. We're going to multiply by 4 to cancel out the fraction, okay? And we end up with A plus B plus C plus D is equal to 28.4 times 4. So 4 times 4 is 16, carry the 1. 4 times 8 is 32, plus 1 is 33, carry the 3. 4 times 2 is 8, plus 3 is 11. So we have one number behind the decimal point in our question, and we have one number behind the decimal point in our answer. So that means A plus B plus C plus D is equal to 113.6. So now I can replace this with 113.6. Okay. So now I want to solve for B, and I want to get rid of this 5. Because it's divided, I'm going to multiply to get rid of it. So 28 times 5, 5 times 8 is 40, so put a 0, carry the 4. 5 times 2 is 10, plus 4 is 14. So 113.6 plus E is equal to 140. So now I'm going to subtract 113.6 to get E by itself. And I'm going to get. Well, here I have to borrow, so I'm going to go here and make this a 10. So now this one's going to borrow, making this one a 9, and this one becomes a 10. So 10 minus 6 is 4, bring down that decimal. 9 minus 3 is 6, 3 minus 1 is 2. and 1 minus 1 is 0. So my answer is 26.4 seconds. I hope you got that. I know these algebra kind of ones are more confusing or more challenging. If you need to watch it again, give it another watch. And if you have questions, always feel free to leave me a comment below, and I'll be more than happy to help you with it. So number 15 says, the average age of 5 students is 10. If a new student is added to the group that is 13, what is the new average of the group of students? So this one is similar. We have 5 students, A, B, C, D, E. When we take their average, we get 10. But in this new scenario, A, B, C, D, E, a new student is added to the group, and it gives us a student's age, 13. And it asks us, what is the new average? Well, we have to figure out what this is right here to be able to add it to the 13. The thing is, we just multiply by 5, and when we do that, we get that by itself on one side of the equal sign. So A plus B plus C plus D plus E is equal to 10 times 5, which is just 50. So it's 50. 50 plus 13 divided by 6. 50 plus 13 is 63 divided by 6. Let's figure that out. 6 goes into 6 one time. 6 times 1 is 6. Bring down the 3. 6 goes into 3 0 times. 3 minus 0, is 3. I added a decimal point. I'm bringing down a 0. 6 goes into 30 5 times. 6 times 5 is 30. 30 minus 30 is 0. So the new average is 10.5. Awesome. I hope you got it. If not, remember, just leave me a question in the comments below, and I'll be happy to help. Good luck. Hey there, this is Alejandra from ASVAB Success, and in this video we're going to go over the questions in the probability review quiz. So let's get right to it. The first question states, the numbers 1 through 10 are written on flashcards and placed into a box. If one card is chosen from the box, what is the probability that the card will be a composite number? So when it comes to probability is always going to equal to the total number of ways that what you desire can happen, and we call this the event. So total number of ways events can happen, and that's going to be divided by the total number of things that could happen, not just what you want, anything completely. So total number of outcomes. So in this problem, what we want is composite numbers. So composite numbers are numbers that you can divide by more than just one and themselves. So this question states that we have the numbers 1 through 10. So the cards have numbers 1 through 10 written on them. In the numbers 1 through 10, the only composite numbers, again, any numbers that you can divide by more than just one in itself, the only composite numbers are going to be 4, 6, 8, 9, and 10.
The reason is because 1 can only be divided by 1 in itself. Same story for number 2, same story for 3, 5, and 7. So how many composite numbers do we have in total? We have a total of 1, 2, 3, 4, 5. So the total number of ways that what we want, the event we want, can happen is going to be 5, because there's 5 composite numbers. I have a total of 10 possible outcomes because there's a total of 10 cards. So your probability is going to equal to 5 over 10. But of course, we can simplify this because we can divide both 5 and 10 by 5, and this will simplify to 1 over 2. So your final answer is that the probability of you getting a composite number is going to be 1 over 2, which is C. Let's go ahead and take a look at number 2. A bag contains 3 yellow marbles, 2 green marbles, and 5 red marbles. If a marble is drawn out randomly from the bag, what is the probability that the marble will not be green? Keyword here being not. So there are 3 options in this bag. There's the 3 yellow, the 2 green marbles, and the 5 red marbles. So let's go ahead and add those up together to know how many marbles in total are in the bag, and we have a total of 10 marbles. So again, probability here is going to be the number of ways in which you will not get green. So how many options do we have that are not green? Well, we have a total of 5 that are red, and we have a total of 3 that are yellow. So if we add the 3 yellow plus the 5 red ones, that's going to give us 8 options that we have out of a total of 10 marbles, 10 possible outcomes here. So once again, the probability here is going to be 8 over 10, but you always want to simplify. So what number can I divide both 8 and 10 by? Well, I can divide both of them by 2. So that will give me that my final answer is going to be 4 over 5. So the probability of not getting green is going to be 4 over 5, which would be D. Let's take a look at the next one. A stack of flashcards has one of the letters of the alphabet written on each one. There's a total of 26 cards, 1 for each letter. If a card is randomly chosen from the stack, what is the probability the card is a vowel? Hint, do not include Y. So here, you should already know that at the bottom, as the total number of outcomes that we have, we're going to have the total number of cards that we have, which is 26. Now, they mentioned specifically not to include Y as a vowel. So what are our vowels? We have A, E, I, O, U, which is a total of 5 cards. So that means that the probability of getting a vowel, you only have 5 possible ways to get a vowel out of a total of 26 cards on the stack. Now, we cannot simplify 5 over 26 by anything because they don't have any factors in common. So that's it. Your final answer is going to be 5 out of 26, which in this case would be B. Let's take a look at the next one. A pizza restaurant allows you to choose a topping for your pizza. The topping choices are pepperoni, bacon, tomato, cheese, onions, mushrooms, sausage, and pineapple. If you can choose one topping at random, what is the probability that it will be a meat topping? So, you probably already know that the first thing I'm going to do is I'm going to count how many topping options do I have in total. So I have pepperoni, bacon, tomato, cheese, onions, mushrooms, sausage, and pineapple. And that's going to give me a total of 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes, 8 possible toppings I could choose. Now, I specifically want to see what is the probability of getting a meat topping. So what are the only meat toppings that I have here? I have pepperoni, bacon, and sausage are the only 3 meat options. So that means I'm going to have here 3 over 8. 3 meat options out of a total of 8 options for toppings. So again, there's nothing we can do here to simplify 3 over 8. So I'm going to go ahead and simply mark my answer as 3 over 8. Next one. John is at a charity dinner where there are 200 guests in total, including himself. There is a raffle for a vacation in the Bahamas, and John purchased a raffle ticket. If 35% of the guests purchase a raffle ticket, what is the probability that John will win the raffle? So we're still working with probability here, but we sprinkled in a little bit of percentage. So in order to figure out what is the total number of raffle tickets, we need to figure out what is 35% of the 200 guests that showed up. So I'm going to start by first calculating this using my percent proportion, which is going to be my part over whole is equal to percent over 100. Now, the percent that I have is 35, so I'm going to go ahead and put 35 here. And the whole is going to be the total number of people attending, which is 200. The part will represent the number of people who bought a raffle ticket, which in other words means the number of raffle tickets. Once you set up your proportion, you're going to cross multiply and divide. So the total number of raffle tickets is going to equal to 35 multiplied by 200 divided by 100. Now here, you can go ahead and multiply 35 times 2, which is going to give you 70. And since there's 2 zeros, we're going to add the 2 zeros at the end, divided by 100. 0 cancels with 0, 0 cancels with 0. So you're left with your final answer of raffle tickets is going to be 70. So you have 70 raffle tickets. We needed this because for our probability, you're going to need to know what is the total number of possible tickets that could be picked out, which is 70. Now, if John wants to win, there's only one way that John can win. His ticket gets picked. So the only possible way for this event to occur is one ticket. John's ticket gets picked out of a total of 70 tickets. Once again, we want to make sure we simplify this. There's nothing more we can do to simplify. So your answer is that the probability that John will win is 1 out of 70, which in this case is B. So hopefully by now you're starting to see the pattern in which probability is going to be calculated by dividing the total number of ways your desired event can happen, divided by the total number of possible outcomes. The next question says, you roll a 6-sided die. What is the probability that you will roll an even number? So think of a dice. Each side of the dice has the numbers 1, 2, 3, 4, 5, 6. How many even numbers do we have? We have 2, 4, and 6. So the probability here is going to be, we have a total of 6 possible ways your dice can land, and there's only 3 even numbers. And you want to make sure you simplify your answer. Can I simplify this? Yes, because I can divide both 3 by 3 and 6 by 3. So that means that my final answer for probability will be 1 over 2. So your probability of rolling an even number is 1 over 2, which in this case is C. Next one. You ask a friend to think of a number from 11 to 17. What is the probability that his number will be an even number? So very similar to our previous question. So to give you a better idea, list out the numbers from 11 to 17. So we have 11, 12, 13, 14, 15, 16, 17. Now let's count how many numbers in that list are even. 12 is even, 14 is even, 16 is even. So your probability that this random number that your friend is going to think of is going to be, there is a total of 1, 2, 3, 4, 5, 6, 7 numbers that are options. And only 3 of them are even. So you're going to have 3 over 7. Can you simplify this? No. So your final answer is the probability your friend picks an even number between 11 to 17 is 3 over 7, which is D. Next one. A bag contains different sports balls. The ratio of basketballs to soccer balls to volleyballs is 2 to 3 to 2. If the coach reaches into the bag and pulls out a ball, what is the probability that the ball will be a basketball? So, again, we're still working with probability, but we sprinkled in a little bit of ratios. So, here the ratio is 2 to 3 to 2. The order of the numbers matches the order of the description. So, they first mentioned basketball, so this first number goes with the basketballs. Now, the second one is for soccer, and the last one is going to be for the volleyballs. So, if the coach reaches into the bag and pulls out a ball, what is the probability that the ball will be a basketball? Well, you're going to need the total number of sports balls that you have in the bag. How are you going to get that total? You're going to add up the numbers in your ratio. So, if you add up 2 plus 3 plus 2, you're going to get a total of 7. So there's a total of 7 sports balls in the bag. Okay? Or at least in the ratio, there's a total of 7. This means that if there's only 7 sports balls in the bag, 2 of them are going to be volleyballs, 3 of them are going to be soccer, 2 of them are going to be volleyballs. Okay? I'm sorry, 2 of them are going to be basketballs, 3 soccer, 2 volleyballs. So again, why do I need that total? Because for my probability, I need to always know what is the total number of outcomes. There's a total of 7 sports balls. Now the question is, what is the probability that the ball will be a basketball? So what does the ratio tell us? The ratio tells us that if there's only 7 balls, there's 7 sports balls, 2 of them would be basketballs. So here's your probability, 2 out of 7. Can you simplify that? No. So this is your final answer, 2 out of 7, which would be D. In the next question, it states, Kelly did not study for her history test. If she guesses on 3 questions by choosing the answer randomly, and each question has 5 answer choices, what is the probability that she will get all 3 questions right? So this is what we call kind of a composite probability, because we need multiple events to happen. We need her to guess the first question right, the second question right, and the third question right. When you need multiple events to happen, you need to multiply the probability of each of those individual events. Thankfully here, all the events are the same, but we're still going to calculate it, multiplying each individual probability. So we have that she needs to get number 1 right, she needs to get number 2 right, and she needs to get number 3 right. Now the question states that each question has 5 answer choices. So let's just focus on number 1 for a second. So for number 1, there's a total of 5 answer choices, and she has to get the right one, and there's only 1 correct answer. So the only way for her to guess it right is that she picked the one answer that happens to be correct. So the probability of getting number 1 correct is going to be 1 over 5. Now, thankfully, all the other questions have the same number of possible answers, so the probability of getting number 2 right is once again going to be 1 correct answer out of 5 answer choices, and the probability to get number 3 right is going to be 1 correct answer out of 5 possible choices. So we have the probability of each individual event, each individual question. Now, to calculate the probability that she will get all 3 of these correct, you're going to multiply all of these 3 probabilities together. When you need multiple events to occur, you need to multiply the probabilities. So we're going to go ahead and multiply this. So we're going to have 1 times 1 times 1 is going to equal to 1 over 5 times 5 is going to give you 25. 25 times 5 is going to give you 125. So the probability of her getting all 3 of these questions right is going to equal to 1 over 125. Nothing we can do to simplify it, so this is your final answer. 1 over 125, which is going to be C. Next. The word elephant is written with each letter on a separate card. If the cards are placed facing down on a table and a person picks up one card randomly, what is the probability that the letter on the card will be a vowel? So this is very similar to the alphabet question that we looked at a few minutes ago. So we're going to go ahead and just write out the word elephant. Now the question states that we want to randomly pick a vowel. So how many vowel options do we have? Well, we have this E, and this A. So the probability is going to equal to, there's a total of 1, 2, 3, 4, 5, 6, 7, 8 letters, and only 3 of them are vowels. I cannot simplify this, so this would be my final answer. 3 out of 8, which would be D. The next question states, a girl is shuffling a stack of playing cards. The playing cards are a standard stack with 52 cards and 4 suits. She draws 1 card from the stack. What is the probability that the card she draws is a spade? So for a second, think about just a standard stack of cards. So you have your diamonds, your spades, your clubs, and your hearts. I forgot for a second. Your hearts. Now, each suit has the card starting from A, and it goes 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King. So each suit is going to have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 cards. And of course, there's 4 suits, and if you multiply 13 times 4, you do in fact get 52, which is the total number of cards in the stack. So let's say these are all spades. So let's say these are all the spades cards. So there's a total of 13 spades cards out of a total of 52 cards in the stack. So the probability of you picking up, or this girl picking up a spade when she randomly chooses a card, there's a total of 52 cards, and only 13 of them are spades. Now, can we simplify this? Yes, because 13 can be divided by 13, and 52 can be divided by 13. So here the probability is going to equal to 13 divided by 13 is 1, over 52 divided by 13 is 4. So the probability that she can randomly pick a spade out of a standard deck of cards is going to be 1 over 4, which is A. Next one. A stack of flashcards has 1 of each letter of the alphabet in each one. There are 26 cards in total, 1 for each letter. If a card is randomly chosen from the stack, what is the probability that the card is 1 of the letters in the word 5? So let's look at the word 5 for a second. So we have the word 5. How many letters does the word 5 have? It has a total of 4 letters, which means there's a total of 4 cards that you can pick up that would be 1 of the letters in 5. So probability, how many cards in total? There's 26 cards. How many cards could possibly be a letter in the word 5? There's only 4. We simplify our answer. I can divide 4 by 2. I can divide 26 by 2. So the probability is going to equal to 4 divided by 2 is 2, over 26 divided by 2 is 13. So the probability that you pick up a card that happens to be 1 of the letters in the word 5 is going to be 2 over 13, which is going to be D. Next question. You roll a 6-sided die. What is the probability that you will roll a number greater than 6? So once again, I'm going to take a look at my options. I'm going to take a look at, well, how many numbers in a 6-sided die are greater than 3? So here are the number options in your 6-sided die. How many of them are greater than 3? Only these 4. Only these 3. So your probability is going to equal to a total of 6 possible ways this dice could land, and only 3 of them are greater than 3. We simplify our answer by dividing both the top and bottom by 3, and the probability here will be equal to 3 divided by 3 is 1 over 6 divided by 3 is 2. So your probability of rolling a number that is greater than 3 is going to be 1 over 2, which is C. And here you have all the questions from the quiz of the probability review. Hope it helps. Okay, so let's take a look at this first time word problem. It says, it takes Keon 14 minutes to read one page of his book. Keon has 8 pages to read, and he began reading at 3:48. At what time will he finish reading the 8 pages? When I'm working with time word problems, I find it most helpful to draw myself a timeline. So I'm going to go ahead and draw myself a timeline here. And this timeline may need to be longer or shorter. It depends on the problem, but for now, let's go ahead and start here. So I like to work in 30-minute intervals. So I'm going to mark this as 3:30. Since he started at 3:48, I'll start a little bit behind. 3:30. Let's make this 4, 4:30, 5, 5:30, and finally, this would be 6 p.m. So this is my timetable. Now, in this timetable, I'm going to be able to kind of like see like the points at which I start, where I'm at. So he started reading at 3:48, so I'm going to mark that. Going to be around here. So he started reading at 3:48 p.m. Now, he has a total of 8 pages to read, and it takes him 14 minutes. So if I multiply the number of minutes it takes me to read one page times the number of pages, I'm going to know how much time I need. So I'm going to multiply 14 times 8. That's going to be 32. Carry the 3. That's going to give me 8 plus 3 is 11. So I'm going to need a total of 112 minutes to read the 8 pages. Now, you can go ahead and jump 112 minutes on this timeline, although it may be a little tricky to do so. So instead, what I'm going to do is I'm going to say, well, if I have 112 minutes in total, what would happen if I extract an hour out of that? So what would happen if I subtract 60 minutes, meaning I wasted an hour, right? So when I subtract here, I'm going to have 2, and it's going to be 5. So that means that 112 minutes is equivalent to 60, which is 1 hour, plus 52 minutes. That's going to be easier to work with in my timeline. So from 3:48, I can jump the first hour, and that's going to land me at, for being realistic, more or less it should land me around here. So this would be 4:48, right? Now, 52 minutes is almost a whole other hour, right? So if I were to jump another hour, it would land me at 5:48. But it wasn't actually an entire hour. Instead, it was only 52 minutes. So it was 8 minutes less than an entire hour. So I'm going to rewind myself, 8 minutes, and that would put me at 5:40 p.m. So that means that at 5:40 p.m., he finished reading his 8 pages. Again, I did this problem using the timeline because I think it is very useful. If you have another way of doing it, that's awesome too. Next problem. So in problem number 2, we have Hilda wants to see a movie before going to her appointment at 3:30. The movie starts at 1:15 and is 87 minutes long. If she has to drive 12 minutes from the movie theater to her appointment after watching the movie, does she have enough time to watch the movie? So in this problem, I'm going to once again use a timeline to help me organize myself. So I like to go in intervals of half hours. So seeing that the movie starts at 1:15, I'm going to start at 1 p.m. And then here I have 1:30, 2 o'clock, 2:30, 3, 3:30, 4, and I guess we'll finish at 4:30. Again, this might need to be longer, but we'll see. So at what time does the movie start? It starts at 1:15. So here, the movie starts at 1:15. Now, it says the movie is 87 minutes long. So let's see, at what time will the movie finish? Well, out of those 87 minutes, instead of seeing as 87, I'm going to say, well, how many hours and minutes is that? If I extract, in other words, if I subtract 60 minutes, that means I'm extracting an hour, and whatever's left over is the extra minutes. So this is going to be 7 and 2. So 87 minutes is equivalent to 1 hour and 27 minutes. So let's see where that lands us. So 1 hour after 1:15 would land me at 2:15. And I'm going to add 27 minutes to that. So 15 plus 27, that's going to give me 2. Carry the 1. That would be 3 plus 1 is 4. So that means that the movie is going to finish right around here, which is 2:42 p.m. Movie ends. Okay? Now, she has to drive 12 minutes to get to her appointment. So we're going to have to add another 12 minutes here. So from 2:42, we're going to add 12 minutes. That's going to land us at, let's see, that's going to be 4 and 5. So that's going to land us at 2:54 p.m. She arrives to her appointment. And the appointment starts at 3:30. So the appointment is over here. So she actually does arrive on time because she's going to get there at 2:54 and the appointment is at 3:30. So she's going to be good to go. She will be able to arrive at her appointment at 2:54 p.m. Problem number 3 states, Sam does private tutoring on Wednesdays and Fridays. She worked from 9 a.m. to 1:30 on Wednesday and 11:30 a.m. to 3 p.m. on Friday this week. If she earns $26 per hour, how much did Sam make this week? So, very important part of this problem is that it's telling you a rate. It's telling you $26 per hour. So in order to know how much she made, so I'm going to say money, it's going to equal to the $26 she makes times however many hours she worked. So first let's take a look at Wednesday. So on Wednesday, she worked from 9 a.m. until 1:30 p.m. So let's see how many hours that is. Well, from 9 to 10, we have 1 hour. 11 is 2 hours. 12 is 2 hours. 1 is equal to 1, 2, 3, 4 hours, and then an extra 30 minutes. So it's equal to 4 hours and 30 minutes, which is the same thing as 4.5 hours. Now this is on Wednesday. Let's take a look at Friday. So on Friday, she worked from 11:30 all the way until 3 p.m. So from 11:30, we have 12:30, 1:30, 2:30, and then we have the extra half hour until 3. So we have 1, 2, 3 hours, and then the 30 minutes. So we have 3 hours and 30 minutes, which is the same as 3.5 hours. So I'm going to take the hours she worked on Wednesday and add it to the numbers that she worked on Friday. This is going to tell me the total number of hours she worked for the week. So I'm going to have 4.5 plus 3.5. That's going to be 0, carry the 1. That's going to be 8. So she worked a total of 8 hours that week. Those 8 hours are going to come in here. So I'm going to have $26 multiplied by 8 is going to tell me how much money she made. 26 times 8, that will be 48, carry the 4. That will be 16 plus 4 would be 20. So she's going to make a total of $208 for this particular week. The next problem states, a class visits a museum for a field trip. They arrive at the museum at 10:22 a.m. If they have a half-hour lunch and must leave at 1:30, how much time does the students have to explore the museum? So, a timeline is going to be very helpful here. They arrive at the museum at 10:22, so I like to work in 30-minute intervals just to keep things organized. So I'm going to mark this as 10, 10:30, 11, 11:30, 12, 12:30, 1, and they got to be gone by 1:30. So, they arrive at 10:22, which would be around here. 10:22, they arrive. Right? Now let's calculate how much time in total do we have from 10:22 until 1:30, which is when they have to leave. So from 10:22, if we add an hour, we're at 11:22. Add another hour, 12:22, and then finally 1:22. So we have 1, 2, 3 hours. Plus we have a little gap here because remember this is 1:22. So from 1:22 to 1:30, we have an extra 8 minutes. So let's convert that completely to minutes. 3 hours and 8 minutes. How much is that going to be? So we have 3 hours, which is equal to 3 times 60 because there's 60 minutes in each hour, which is going to give me 180 minutes. And I'm going to add the extra little 8 minutes there. Oops, sorry about that. We're going to add the extra 8 minutes. So we have a total of 188 minutes from the moment we arrive to the museum until we have to leave. But we have to keep in mind that they have a half-hour lunch. So from that 188 minutes that they have to roam around, we're going to have to deduct 30 minutes for lunch. So in reality, they're going to have 158 minutes to roam around and explore the museum. So we have 158 minutes in total. This problem states, Mira went to her friend's house. It took her 18 minutes to drive from her house to her friend's house. She spent 87 minutes at her friend's house, then she drove 10 minutes to the supermarket. She shopped for 31 minutes and drove for 17 minutes to get home. If she left her house at 10 a.m., at what time did she return home? So this is quite a lot of information being given here. What I think is best for you is to calculate in total how long was she out of the house. And I think it would be helpful to first calculate it in minutes, and then we'll see if converting them to hours will be helpful. So let's gather all the information we have. So she drove 18 minutes to her friend's house. So we have 18 minutes. Plus, she was at her friend's house for 87 minutes. So we're going to add 87 minutes to that. Plus, she drove 10 minutes to the supermarket. And finally, well, actually, no, not finally. She stayed shopping for 31 minutes. And then finally, she drove 17 minutes to get home. So let's see how much time did she spend out of the house. Let's add this all up. 8 plus 7 gives us 15, plus 1 gives us 16, plus 7 gives us 23, carry the 2. 2 plus 1 is 3, 3 plus 8 is 11, 11 plus 1 is 12, 12 plus 3 is 15, and 15 plus 1 is 16. So she was out of the house for a total of 163 minutes. So we're going to see, what is that going to look like in our timeline? So here's my timeline. So I'm going to start it at 10 a.m., and I'm going to work in 30-minute intervals. So here's 11, 11:30, 12, 12:30. We'll see if we need to extend that a little longer. So she left her house at 10:10 a.m. So right around here, she left her house, 10:10 a.m. Now, she was out of the house for a total of 163 minutes. If you want, you can work just with 163 minutes. I think it'll be better for us if we see how much is that in terms of like hours and minutes. So to figure out how much it's going to be in terms of hours and minutes, I'm going to deduct 60 minutes, which is going to be 1 hour. So I'm going to deduct 60 minutes, and I'm going to be left with 103 minutes left over. So far, I deducted 1 hour. Because 103 is more than 60, I know there's definitely another hour in there. So I'm going to deduct another 60. This is going to become 0, so this can become 10, but then we're going to take away 1 to become 9. Oh, actually, no, I'm sorry, let me back that up. I'm so sorry. No need to borrow. 3 minus 0 is 3, and now 10 minus 6 is going to be 4. There we go. Apologies. So this is going to become another 1 hour, and now we have 43 minutes. So how long was she out of the house? 163 minutes is equivalent to 2 hours and 43 minutes. So let's see where that lands us on our timeline. We add an hour to this, and we land at 11:10. Add another hour, and we land at 12:10. We're going to need to add 43 minutes to that. And I see I'm going to need to extend my timeline a little bit. So 43 minutes. So 43 minutes here. If I jump from 12:10, I'm going to jump 10 minutes, 20 minutes, 30 minutes, 40 minutes. So this is going to land me, this is going to be, oh, I'm sorry, once again, made a little mistake. Let me go back. I'm sorry about that. So this is why you should write down the time instead of just doing it in your head. So 12:10 lands me, 10 minutes later, it's 12:20. 10 minutes later, it's 10:30. 10 minutes later, it's 12:40. And another one, it's 12:50. But that's only equivalent to 40 minutes, and I have 43 minutes. So I'm going to add just 3 more minutes to that. So that's going to put me at 12:53 p.m. Okay? So she got back home at 12:53 p.m. Another way you could do this, and again, I stick to the method of timelines because they're very helpful regardless of what time work problem you have. But once you knew that you had 2 hours and 43 minutes, you could also take the initial time of 10:10 and add the 2 hours and 43 minutes, and you would once again get 12:53. Now, why didn't I go directly to this? It's honestly just a force of habit of doing the timeline. I also know that you have to be careful with time because, again, time doesn't work like regular numbers. You don't like add up to 100 or anything like that. It's technically like a full hour is 60. So the timing can, not to put a pun on it, but the timing can get a little bit tricky. So I like to stick to timelines, but if you prefer just adding the time, that is perfectly fine as well. The next problem states, the students were taking a written exam portion that lasted 75 minutes. If the exam began at 9:22 a.m., at what time does the exam finish? So, a total of 75 minutes. I want to know what that's going to be in terms of hours and minutes. So I have 75 minutes. if I extract 60 minutes out of that, in other words, an hour, what am I left with? I'm left with 5, 1. So 75 minutes is equivalent to, this is 1 hour and 15 minutes. So 75 minutes is the same as 1 hour and 15 minutes. So we started the test at 9:22 a.m. We have to add to that 1 hour and 15 minutes. So here I'm going to have 2 plus 5 is going to give me 7, 2 plus 1 is 3, and this is going to give me 10. So this written portion of this test should be done by 10:37 a.m. You can also find the answer using your timeline, jumping 1 hour and then adding an extra 15 minutes to 9:22. You would still get the same answer. This problem states the teacher was proctoring the exam. The exam began at 8:46 a.m. and the students were given 55 minutes to complete the exam. The teacher was given a 10-minute warning before the exam ends. At what time was the teacher give the 10-minute warning? So, given that she has to give a 10-minute warning, she has to say it 10 minutes before the exam is done. If the students had a total of 55 minutes to complete the exam, 10 minutes before that would be 45 minutes. So what we need to see is the 10-minute warning will be given 45 minutes after the test starts. So if the test started at 8:46 a.m., I'm going to draw myself a little timeline. Now, why can't I just add 45 here? Because if you add this and you get 1, carry the 1, that's going to be, let's see, that's going to be 8 plus 1 is 9, that's going to be 8. There's no such thing as 8:91 a.m. because time doesn't work that way. So I think it's helpful to just draw your timeline. You started at 8:46. So you started at 8:46 a.m. You're going to get this warning 45 minutes later. So I'm going to mark this as 8:30. This is going to be 9. This is going to be 9:30, and this is going to be 10. So 45 minutes later is going to put me at, if I add 30 minutes to 8:46, 30 minutes is going to be, let's see, I'm sorry, not 30 minutes, 45 minutes. I apologize. We're adding 45 minutes here. So 8:46, I'm going to jump 10 minutes, and that's going to leave me at 8:56. Add another 10, that's going to be 9:06. Add another 10, 9:16. Add another 10, now it's 9:36. But that's only 40 minutes because each of these was 10 minutes. These are each 10-minute jumps. So that's 40. But it's 45 minutes in total. So I'm just going to add 5 more minutes to that. So 9:36 plus 5 would finally land me at 9:41 a.m. Oh no, I messed up. Where did I mess up? 8:46 plus 45. That's going to be 56, 06, 60. Oh, because I went to 36. It was 26. Tee-hee-hee, silly me. Okay. Okay, I'm going to restart this problem. Sorry, I'm going to restart this problem. Okay, so hopefully you can cut all that out and I hope I made you giggle. Okay, so restarting this problem in 3, 2. Okay, so this problem states the teacher was proctoring the exam. The exam began at 8:46 a.m. and the students were given 55 minutes to complete the exam. The teacher was given a 10-minute warning. Was given a warning 10 minutes before the exam ends. At what time does the teacher give a 10-minute warning? Well, if the teacher has to give a 10-minute warning 10 minutes before the exam ends, well, the students have 55 minutes in total. Subtract 10, so she has to give the warning 45 minutes after the test starts. So the test starts at 8:46 a.m. We're going to need to know where are we 45 minutes after that. So small timeline. I'm going to start at 8:30, 9, 9:30, 10, 10:30. The test starts at 8:46, which is going to be around here. Now we're going to add 45 minutes to this, and I like to go in intervals of 10, so that's what we're going to do here. We add 10 minutes, and this is 56. We add 10 minutes, we're at 9:06, 16, 26. Now that's equivalent to 40 minutes, but we're doing a total of 45 minutes, so we're going to do just a small jump of 5 more minutes. 26 plus 5 would land me at 31. So the warning is going to come in at 9:31 a.m., which is 45 minutes after the starting time of 8:46. This problem states Maria turned on the oven at 6:10. The oven took 15 minutes to warm up. She put in a tray of cookies after the oven had warmed up and baked them for 22 minutes. At what time did Maria take the cookies out of the oven? So let's see in total how much time has passed from the moment she started baking to the moment that her cookies were supposed to come out. So the oven took 15 minutes to warm up. So it's going to be 15 plus. She had to leave the cookies in the oven for 22 minutes. So let's see, that's going to give us a total of 7, 3. So a total of 37 minutes from the moment she started to now when she's going to take out the cookies. So she started at 6:10 p.m. We're going to add 37 minutes to that. So that means that she's supposed to take out the cookies at 6:47 p.m. So 6:47 p.m. she's taking out the cookies. This one states Rem left his house at 8:15 and drove to work. His commute was 32 minutes long. At what time did he arrive at work? So he leaves the house at 8:15 a.m. He has to drive for 32 minutes. So we're going to add 32 minutes here. So 5 plus 2 is going to give me 7. 1 plus 3 is going to give me 4. So he arrives at work at 8:47 a.m. This one states Tracy left her house for work at 8:10. She takes 10 minutes to walk to the train station, and it takes 13 minutes for the train to arrive. When she gets off the train, it takes 24 minutes for her to walk to her office. If she needs to be at work at 9:30 a.m., how much time does she have for the train ride to work? So we have a starting time, and we have an expected ending time. She needs to be at work by 9:30. So in our timeline, so we start at 8. So 8:30. Actually, let me space this out even more. So I'm going to put here 8:30, 9, and 9:30. She leaves her house at 8:10, which is more or less around here. Oops. She leaves her house at 8:10, and she needs to be at work by 9:30. So let's see, how much time is there from the moment she leaves her house until she's expected at work? So 8:10, if I add an hour, it's 9:10. That's 1 hour. And then from 9:10 to 9:30, it's 20 minutes. So she has a total of 1 hour and 20 minutes. Let's convert that to minutes completely. 1 hour is the same thing as 60 plus 20. So she has a total of 80 minutes from the moment she leaves work until she's expected out. I'm sorry, from the moment she leaves home until she's expected at work. From those 80 minutes, we're going to deduct all the time we know she's going to take between the walking and the waiting and the walking. It takes her 10 minutes to walk to the train station. So let's subtract the 10 minutes she takes to walk. She's down to 70 minutes. Then she has to wait for the train, which takes 13 minutes. So we subtract another 13 minutes. That's going to leave us at, so let's see, it's going to be 6. That's going to become 7. And that's 57 minutes that she has after she waits for the train. Now it takes her 24 minutes to walk to her office. So let's subtract another 24 minutes from that. And that's going to give you 3 and 3. So she has a total of 33 minutes that she could possibly use for the train ride to work. So again, we calculated the total amount of time that she had, and we deducted slowly all the time that we knew she would take from the walking, from the waiting, and then from walking again. This problem states it takes Gibran 7 minutes to read one page of his book. Gibran has 5 pages to read, and he began reading at 2:14. At what time will Jason, I believe that's supposed to say Gibran. That's okay. Gibran. At what time will Gibran finish reading the 5 pages? So, here, we have a timeline. So let's see. 2, 2:30, 3, 3:30. And I'll go ahead and just make this a little longer. And here's 4 o'clock. He starts reading at 2:14. So 2:14 is right around here. 2:14 p.m. He has 5 pages to read. Each one takes 7 minutes. So we're going to multiply the number of pages times how much time he takes for each page. And that's going to equal to 35 minutes. So he's going to spend 35 minutes reading. So I'm going to add these in intervals of 10. So from 10:14, we add 10 minutes, and now it's, I'm sorry, not 10:14, 2:14. We add 10 minutes, and it's 2:24. We add another 10 minutes. Now it's 2:34, and now we add another 10 minutes, and now it's 2:44. But that's only 30 minutes in total. He read for 35 minutes. So 2:44 plus an additional 5 minutes is going to land us at 2:49 p.m. is the time in which he's going to be done reading his book. The next problem states, Katie wants to see a movie before going to her appointment at 2:30 p.m. The movie starts at 12:15 p.m. and is 99 minutes long. If she has to drive 14 minutes from the movie theater to her appointment after watching the movie, does she have enough time to watch the movie? Well, let's see. Start with our timeline. So she has to be at her appointment by 2:30 p.m. I'm going to start this at 12 o'clock. 12, going by intervals of 30, I'm going to be at 12:30, 1 p.m., 1:30. Her movie started at 12:15. So 12:15 p.m. she started her movie. It takes 99 minutes for the movie. So I'm going to convert those 99 minutes. I'm going to see how much that is in terms of hours and minutes. If I deduct 60, that means I'm extracting 1 hour out of this. I'm going to be left with 9 and 3. So that means that 99 minutes is equivalent to 1 hour and 39 minutes. So let's see where that lands me. So the movie takes an hour and 39 minutes. So 1 hour after 12:15 lands me at 1:15. That's 1 hour. And I'm going to add 39 minutes. So let's see. If I jump in intervals of 10, that would be 1:25, 1:35, 1:45. And that's only 30 minutes, but I need 9 more. So 45 plus 9 lands me at, let's see, 45 plus 9. That's going to be 4, carry the 1. So it's going to be 1:54. The movie finishes. Movie ends. She needs to drive 14 minutes. So from that 1:54, let's add 14 minutes. So I'm going to need to extend my timeline here a little bit. Let's put that at 3 o'clock. So she needs to drive 14 minutes. So from 1:54, I'm going to add 10 minutes, landing me at, I'm sorry, I just realized my time here is a bit off. This is supposed to say 2 o'clock, and this is supposed to take 2:30. That makes way more sense. I apologize for that. So this lands us at 2:04. That's an extra 10 minutes. Add 4 more minutes, and she's going to be arriving at 2:08 p.m., and her appointment is at 2:30. So yes, she does have enough time to watch her movie because she will be arriving at her appointment at 2:08, and her appointment's at 2:30, so she's going to have a little bit of time. Luna does private tutoring on Wednesdays and Fridays. She worked from 9 a.m. to 2:30 on Wednesday and 11:30 a.m. to 1 p.m. on Friday this week. If she earns $28 per hour, how much did Mitra, I believe this is supposed to say Luna, how much did Luna make this week? So we know that the total amount of money she's going to earn depends on 28 multiplied by the total number of hours that she has worked. So let's see how much did she work on Wednesday. So on Wednesday she worked from 9 a.m. to 2:30. So from 9 to 10 there's 1 hour, 11 there's 2 hours, 12 there's 3 hours. I'm going to need to extend my line a little bit. 1 and finally 2. So let's see. She worked 1, 2, 3, 4, 5 hours with an extra 30 minutes. So she worked 5 hours and 30 minutes, which is equivalent to 5.5 hours. That's on Wednesday. Now let's see on Friday. So on Friday, she worked from 11:30 until 1 p.m. So 11:30 to 12:30 is 1 hour, and then there's another extra half hour there. So she worked 1 hour and 30 minutes. 1 hour and 30 minutes, which is equivalent to 1.5 hours. Now, to know how many hours she worked for the week, I'm going to go ahead and add 5.5 plus 1.5. 5.5 from Wednesday plus 1.5 from Friday is going to leave me with 0, carry the 1. 6 plus 1 is 7. So she worked a total of 7 hours, and that's what I'm going to plug in here. So the total amount of money that she's going to earn is going to equal to 28 multiplied by 7. So 28 multiplied by 7, 8 times 7 is 56, carry the 5. 2 times 7 is 14, plus 5 is 19. So she's going to make a total of $196. A class visits a museum for a field trip. They arrive at the museum at 8:44 a.m. If they have half an hour lunch and must leave by 1:15, how much time do the students have to explore the museum? So let's see how much time they have in total from the moment they arrive to the moment they have to leave. So I'm going to start this at 8:30. I'm going to go by 30-minute intervals here. So let's see, that's going to be 10, 10:30, 11, 11:30. I'm going to extend my line here. So this is going to be, let's see, 12. Oh, I'm going to have to extend it a little bit more. Let's do 12:30, 1. Oh my goodness, extend it one more time. 1:30, there we go. Okay, so they arrive at 8:44, which is right around here. 8:44, they arrive. They have to leave by 1:15, which is right around here. They have to leave. So let's calculate how much time in total do we have from 8:44 to 1:15. So let's see. 8:44, add an hour, we're at 9:44. Add another one, 10:44. And you can kind of see where I'm going with this. 10:44, 11:44, 12:44. I'm going to stop here. 12:44, that's equal to 1, 2, 3, 4 hours. So we have 4 hours, and we have a little bit more time here. So from 12:44 to 1:15, 12:44, that's going to be, let's see, we add 10 minutes. That lands us at 12:54. Add another 10, it's 1:04. Add another 10, that's going to be 30 minutes, and it lands us at 1:14. So add one more, and that's going to be 31 minutes. So we have 4 hours and 31 minutes. Let's convert that to just minutes. So now how much minutes in total we have from the moment we arrive to the moment we leave. So it's going to be 4 multiplied by 60, given that there's 60 minutes in each hour. That's going to give me 240 minutes, plus the additional 31 minutes. So that means I'm going to have a total of 271 minutes from the moment we arrive to the museum until we got to leave. So 271 minutes in total. Now let's start deducting. Oh, I'm sorry. We have to deduct the half hour that we're going to need to eat. So be careful. They put that 271 there to make you think, oh, you're done. But no, you're not done. Because there's a half hour lunch. You got to eat. So you're going to subtract 30 minutes for lunch, and you're going to be left with a total of 1, 4, 2. So you have 241 minutes for the students to run around the museum and explore. 241 minutes. Irene went to her friend's house. It took her 10 minutes to drive from her house to her friend's house. She spent 105 minutes at her friend's house. Then she drove 30 minutes to the supermarket. She shopped for 36 minutes and drove 15 minutes to get home. If she left her house at 10 a.m., at what time did she return home? Let's calculate in total how much time she spent out of the house. So 10 minutes, 10 minutes to get to her friend's house. She was there for 105 minutes. She drove to the supermarket, which took 10 minutes. She shopped for 36. And finally, she drove home, which took 15. So let's see, how long was she out of the house? 5 plus 6 is 11, plus 5 is 16, carry the 1. 1 plus 1 is 2, plus 1 is 3, plus 3 is 6, plus 1 is 7. And finally 1. So she was out of the house for a total of 176 minutes. Now I want to know, what is that in terms of hours? If I extract 60 minutes out of this, that's equivalent to 1 hour. Let's see what's left over. 6, 1, 1. So after I take out 1 hour, I'm still left with 116 minutes. Since it's more than 60, I know there's 1 more hour in there. So let me do it again. Let's extract another hour. Let's see what's left over. 6, 5. So 176 minutes is equivalent to 2 hours from here and here and 56 minutes. So she was out of the house for almost an entire 3 hours. So she left the house at 10 a.m. and she was gone for 2 hours and 56 minutes. So almost 3 hours. So it might be helpful for us to just work with 3 hours since it's so close. I'll go ahead and just add 3 hours, knowing that I need to deduct at the end. This is not 3 hours in total. I still need to deduct a little bit. So let me just do it that way. So if I add 3 hours here, that's going to put me at, let's see, that's going to be 10 plus 2 gives me 12 plus 1 more hour, right? Technically it would be 13. But if we're working with just time, we can convert that. 13 is the same thing as 1 p.m. So that's going to be 1 p.m. But remember, it wasn't exactly 3 hours. It was 2 hours and 56 minutes. So go back 4 minutes, right? Because 60 minus 56 is 4 minutes. So go back 4 minutes, and instead, you're going to be at 12:56. No, I messed up somewhere. I don't know where I messed up. I honestly lost my way completely as I was going over the problem. And I know I just did another one almost identical to it, and yet I still managed to mess up. I don't even know where I messed up. Oh, because I forgot the 10. Oh, I'm so silly. Okay, I'm going to restart the problem. You don't need to tell me. I feel it in my head that I'm overcomplicating this. I honestly don't know why. I just feel like I don't know how else to explain it. And that's very, very bad of me. I should probably figure that out. Okay. Restarting this problem in 3, 2. Irene went to her friend's house. It took her 10 minutes to drive from her house to her friend's house. She spent 105 minutes at her friend's house, and then she drove 10 minutes to the supermarket. She shopped for 36 minutes and drove for 15 minutes to get home. If she left her house at 10:10, at what time did she return home? So let's calculate in total how long she was out of the house. She was out of the house for 10 minutes driving to her friend's house, 105 that she stayed at her friend's house. Then she drove 10 minutes to the supermarket, shopped for 36, and then took 15 minutes to drive home. So let's see what that's going to equal. 5 plus 6 is 11, plus 5 is 16, carry the 1. 1 plus 1 is 2, plus 1 is 3, plus 3 is 6, plus 1 is 7, and finally 1. This is 176 minutes. Now I want to write that in terms of hours. So what I'm going to do is I'm going to extract 60 minutes from this, which is equivalent to 1 hour, and see how many minutes are left over. 6, and that's going to be 1, 1. So I'm left with 116 minutes. Because that's more than 60, I know I can extract another hour from that. Oopsies. I know I can extract another hour from that, so again, I'm extracting a second hour. And let's see what's left over. 6 and 5. So 176 minutes is equivalent to 2 hours and 56 minutes. So she was gone out of the house for almost 3 hours. So she left the house at 10:10 a.m. If I add an hour to that, that's 11:10. Add another hour, 12:10. So that's the 2 hours. Now we're going to add 56 minutes. 56 minutes is almost an entire hour. So what I'm going to do is I'm going to jump another hour, which would put me at 1:10. But since it's only 56 minutes, 60 minus 56 leaves me with 4. So I'm going to rewind the clock just 4 minutes because I didn't actually spend an entire hour, only 56. So rewind the clock, minus 4, and that brings me back to 1:06 is the actual time that she arrived at home, at 1:06 p.m.
welcome. This is the algebra video. I'm so excited you've gotten this far in our lessons. I really hope that you're getting a lot of great benefits out of the videos. So today what I want to go over with you are the rules for algebra. So we're going to start with the really basic stuff. We're going to understand how to work with variables, adding, subtracting, just the basic stuff, and then we'll go from there, okay? We're going to build on that. So first things first, rules for adding and subtracting variables. So variables are basically, we know the most common one to be x, and x represents something that is unknown. We don't know what is the number yet, so we're just using x as a placeholder. Now x can behave in a couple different ways. When we're adding x, we can do x plus x equals 2x, okay? We can also do x plus 2x equals 3x. The important thing is that when we're adding x's, the number in the front is what we add. And when there's no number, we have an invisible 1. Okay? Now, what if it has an exponent? An exponent is this small number up here. This means x times x. Okay? Now, what if we have x squared plus x? What does that equal? Well, that equals x squared plus x. We cannot add these together. And the reason we can't add them together is because they don't have the same exponent. So here we have an exponent of 2. But in this one, there is no exponent. That means there's an invisible 1. If they do not have the same exponent, we cannot add them together. So if we were to have something like, let's say, x squared plus x, there are no other x's with a square. So we can't add it to anything. So that's just going to stay as x squared. But here we do have an x and an x that have an exponent of 1. So we can add them and we get 2x. Okay? So let's do a couple of practice problems. Let's make it a little more complicated. And just to make sure, if we have x squared plus 2x minus x, I want to make sure that you understand that once again, there's no other x squared, so it stays the same. But this is 2 minus 1. This becomes plus x. Okay? So now that we understand that the rules are the same for adding and subtracting, let's go ahead and get into some practice. So I'm going to zoom this in here so we can focus on just one problem at a time. So here we have an x squared and we have a plus 5x squared. Super important. The sign in the front is the sign that belongs to that number. Okay? So this is 1 plus 5. There are no other x squareds, so we're going to do 6x squared. Okay? Then we have plus 3x minus 2. So this is 3 minus 2. 3 minus 2 is 1, so it's plus x. Because remember, with the variables, the 1s are invisible, okay? We have no other x with with an exponent of 1. So let's do now our last number. There are no other numbers to add or subtract to it, so it's just going to be minus 8. So essentially, we're grouping together everything that is the same. And this is called combining like terms. Okay? We're combining like terms. So we're going to do one more together, and then I want to give you a chance to try that. So we have 3x squared plus x squared. There are no other x squareds, so we're just going to do 3 plus 1, that is 4x squared. Then we have 6 minus 8. These are the only ones that have x's with an exponent of 1, so I'm just going to put these two together, and 6 minus 8 is negative 2. So this is negative 2x. I hope you reviewed positive and negative numbers. If this confused you here, 6 minus 8 is negative 2, pause, go back, look at positive and negative numbers, and then come back, okay? And then here we have negative 9 and negative 14. Negative 9 minus 14 is negative 23, okay? All right, so now that we did that one together, I want you to give this one a try. I'm going to give you a little bit. If you need extra time, don't be afraid to pause the video and take the time you need to figure it out, and then I'll come back and explain it. Okay, so now that you got a chance to work that out, let's take a look on how to solve it. So we're looking for the ones that have the square. So a squared and a squared. So that has a plus in front of it. So this is 1 plus 3. That's 4a squared. So far, so good. Then now we're going to look for the ones with an exponent of 1. So 5a, negative 12a, negative 8a. So 5 minus 12 is negative 7. And we still have to minus 8a. Negative 7 minus 8a is negative 15a. Now that we've done that, what's left is our negative 2. There are no other numbers, so we just leave that just like that. Okay? Hope you got it. Oh, excuse me. I hope you got that. Let me know if you have any questions. You can submit them below in the questions, okay? We got one more. I want you to give this one a try. I'm going to give you a little bit of time also, and then I'll go over it with you. Okay, so I hope you got it. Let me go ahead and show you how to do it. So this one has an n to the third, another n to the third. So this is 1 minus 12. That gives me negative 11 n to the third. Then we have, let's look for the next number, 3n squared minus 8n squared. So 3 minus 8 is negative 5n squared. And then we have 3n minus 2n, and 3 minus 2 is 1, so plus n. Okay, hope you got it. Feel free again to pause and review them again. If not, we're going to move on to rules for multiplying. So when we're multiplying, what we do is we add the exponents. So here this is x to the 1, x to the 1. They're being multiplied together, so I add the exponents and it becomes x squared. In the same way, x squared times x, this is a 2 and 1, this becomes x to the third. Okay? If we have x squared y times xy, we add up the exponents for each variable. So we start with the x. 2 plus 1 is 3. Now we do y. 1 plus 1 is 2. Now, each variable carries its own exponent, so we don't add up the exponents for two different variables, okay? Let's just do one more example. A squared b times abc. We start with a. 2 plus 1, 3. 1 plus 1, 2. And c just has the 1, no other one. So c. Okay? I hope you got that. Let's look at an example together. Now this one has a number. We're going to multiply that number first. There is a 1 here. Remember, those ones are invisible. So it just stays at 2. Here, we have m next. m5 and 4. So this becomes m to the 9th power. And there's only one n, so it stays like that. I hope that made sense. Go ahead and give this one a try. And then I'll come back and I'll explain it. Okay, so here we go. 3 times 5, 15. M, we got a 5 and we got a 1, so it's 6. And then N, we got a 2 and we got a 3, so it's 5. Here you go. Hope you got it. If not, here's one more. Actually, we have 2 more, but work on this one first. I'll give you a little bit of time. Okay, I hope you got it. If not, don't worry. I'm going to go over it now with you. So let's multiply the numbers first. 6 times 3, 18. Then we have A, 4 and 2. That's 6. And B, 1 and 2. That's 3. Some people might multiply these two by accident. That's okay. Remember, what we're doing is we're adding them. Okay? We got one more practice, and then I'm going to show you a different kind of multiplication. Go ahead. Okay, I hope you got it. Let's go ahead and go over it together. So this is a 1 and a 3, so that's 3. Then we have A, that's a 2 and a 5, so it's going to be to the 7th power. We have B, 1 and 2, that's 3. And then we have a C, just one C, so we're going to leave that one just like that. So the next one I want to show you is something called distribution. This is a way of multiplying also. But with distribution, what we're doing is we have parentheses, just like these, and what's on the outside gets multiplied to each thing that's on the inside. So for example, 3 times x is 3x, and 3 times 4 is positive 12. That's it. That's how you do this one. Okay? So another example, if we were to have 3 times x minus 6, for example, it would be 3 times x is 3x. 3 times negative 6, negative 18. Okay? Now that I've done that for you, I want you to give this one a try. I'll give you some time. Alright, here we go. So we're doing 2x times x. Remember, 2x times x, we add the exponent. So that becomes 2x squared. And 2x times negative 6, 2 times negative 6 is negative 12. And the x stays the same. So this becomes minus 12x. Okay? You see. We got one more, and then we're going to go over division. I'll give you a little bit of time to figure this one out, okay? Go for it. Okay, so let's multiply these together. I hope you got it right. If not, don't worry. I'm going to go over it with you right now. We have 2a squared times a squared. So 2 times 1 is 2. A squared is a to the 4th. Now, plus, because that's a plus. 2 a squared times a to the 3rd. 2a to the 4th plus 2a to the 3rd. I hope that made sense. Please submit a question to us if you're not sure about something. I'll be more than happy to provide you an answer. Next thing we're going to talk about is rules for dividing variables. Okay, so here we go. When we divide variables, it looks something like this. Okay? When we divide variables, what we're doing is we're subtracting the exponents. So it's the opposite of what we did with multiplication. So here, the only variable on the bottom is a, and it has an exponent of 1. So we do 2 minus 1 is 1. Because it's positive, it stays on the top. If the answer is negative, we move it down to the bottom. But here it's positive, so it stays on the top, and the b stays the same. Okay? Another example is, let's make it a little more complicated. Here we have a to the 4th minus the 2 from the bottom. So it's a squared, because 4 minus 2 is 2. Here, b, this has an exponent of 1. This is 3 minus 1, so it's also 2. Nothing is negative, so nothing goes on the bottom. What if we do have something that is negative? What does that look like? Let me explain. I will show you. Okay, what if we have something like this, where 1 minus 2 gives you negative 1? We put the a to the 1 power on the bottom because it's a negative, and the b stays on top. One more time. Let's say we have xy squared over x squared y. 1 minus 2 is negative 1 for the x, and 2 minus 1 is positive 1 for the y. Because it's negative 1, the x goes on the bottom. Because it's positive 1, the y goes on the top. Okay, so let's look at an example together. Go ahead and try it out. Actually, no, I'm going to explain this one too, because this one's a little bit different. So we're going to do here, 2 minus 1 is 1, and it's a positive 1, so it's going to stay on top. And b, 1 minus 1 is 0, which means it cancels out. And all we're left with is a. Okay, so that one's a little bit different. I want you to go ahead and give this one a try. I'll give you a couple of seconds. Pause the video if you need to, if you need a little more time to figure it out, and go back and look at the notes, okay? And I'll come back in just a bit to explain it to you. Good luck. Okay, here we go. So here, we have a number on the top. There's nothing to divide on the bottom, so it stays the same. A to the 4th and a to the 1 on the bottom. So 4 minus 1 is positive 3. And for b, we have 1 minus 3, which is negative 2, which means it's going to go on the bottom, b squared. When we put it on the bottom, excuse me, when we put it on the bottom, we don't put a negative, we just put it on the bottom, okay? Just in case that's a question you had. Okay, I hope you got it. If not, don't worry. Here's another one for you to try out. I'll give you a couple seconds to do it, and then I'll go over it with you. Okay, so let's work this one out together. Here, we have 12 divided by 4. With numbers, we divide them regular. 12 divided by 4 is 3, so that one goes on top. 5 minus 1 is 4, positive 4, so it goes on the top. And then we have 1 minus 3, which is negative 2, so it goes on the bottom. So 3a to the 4th over b squared. But the next thing I want to go over with you is solving for an unknown. So solving for an unknown is usually questions that look like this, okay? How do we solve questions that look like that? Well, essentially what you want to do is you want to get the x by itself on one side of the equal sign. Think of it as your ultimate goal. Your ultimate goal is to get x by itself on one side of the equal sign. So if we have x plus 1 equals 2, the x is not by itself because it has a 1 by it. So how do we get rid of the 1? We get rid of the 1 by doing the opposite operation. So here this is a plus, the opposite would be minus 1. And when I minus 1, I have to do it on both sides of the equal sign. Whatever I do on one side of the equal sign, I must do to the other. So when I do that, I cancel this out, and I'm left with x by itself on this side of the equal sign. I bring down my equal sign, and then I do 2 minus 1, which is 1. Okay? Let's do one more example. So we have x minus 3 equals 5. How do I get x by itself? Well, it has a 3, and it's minus, so I have to do the opposite. So I'm going to do plus 3, plus 3. That cancels out. Now I'm left with only x on this side. I bring down my equal sign, and 5 plus 3 is 8. So x equals 8. You know what? There's a couple other ones I want to go over with you. So let's say I have 3x equals 12. Here, the x is not alone because 3 is multiplied to the x. So how do I get the x alone? I divide, because that's the opposite of multiplication. And whatever I do to one side of the equal sign, I do to the other side of the equal sign. So I cancel this out, and x equals 12 divided by 3, 4. Let's say I have x over 3 equals 2. Here, the x is not by itself. Once again, it is being divided by 3. So I do the opposite. What's the opposite of division? Multiplication. So I multiply by 3. I do the same thing to the other side, because whatever I do to one side of the equal sign, I must also do to the other. So when I multiply, I cancel that out, and I'm left with the x here by itself. And 2 times 3 is 6. Let's look at another example together. Actually, you know what? Give this one a try. I've gone over a couple examples. I want you to give this one a try. I'm going to give you a couple seconds, and then I'll go over it with you. Okay, I hope you got it. If not, don't worry. I'm going to explain it to you now. So I'm going to do minus 4, because I want to get the x by itself, and that 4 is added to the x. I'm going to do the opposite, so I'm going to subtract 4. And I'm also going to subtract 4 from this side. So x equals 10 minus 4 is 6. X equals 6. Awesome. Now that we got that one, why don't you give this one a try? This one is 2 steps. I want you to try and do what you think you need to do, and then I'll go over it with you. Okay, I hope you got it. If not, no worries. First thing we're going to do is we're going to get rid of what's furthest away from the x. So this 2 is real close. So let's work on the 3 first. So we're going to do minus 3 minus 3. 2x equals 12. Okay? Then, remember our goal is to get the x by itself. We can't yet because we need to divide by 2. This cancels out, and it becomes x equals 6. Okay? So, now that I've done that, I want you to give this one a try. It's a little more complicated, but remember, the goal is to move things around so the x is by itself on one side of the equal sign. Go ahead. Okay, I hope you got it. First thing I want to do is I'm going to minus the x here. And I'm going to do it from both sides. The reason I want to do that is because I don't like that the x is on both sides of the equal sign. Now I've canceled it out, and now I only have it on one side of the equal sign. So 2x minus x, or 2 minus 1, is x. So now I bring everything else down, the plus 4 and the negative 11. Okay? Remember, the sign in front belongs to that number. Now I'm going to minus 4, and I'm going to minus 4. This cancels out. Negative 11 minus 4 is negative 15. Okay? All right, I hope you got it. Here we got another one. If you notice, this one has the distribution. We went over that already. I hope you still remember how to do it. So give it a try, and then I'll come back and I'll show you. Okay, I hope you got it. If not, no worries. I'm going to explain it now. So what we do first is we distribute that 3, right? So 3 times x is 3x. 3 times negative 8 is negative 24. Bring down everything else. Then I'm going to minus 2x because I want everything on one side of the equal sign. So 3 minus 2 is 1. And remember, 1s are invisible. X minus 24 equals negative 1. Now I still want the x by itself. I have a 24 subtracted from it. Now we're going to do plus 24 plus 24. So x equals 23. I hope you got it. If not, feel free to pause, rewind, go over it again. There is a practice at the end of this module so that you can practice everything that you've learned and make sure that you got it, okay? If you have any questions, remember to submit a question in our form. All right, good luck with your studying. Hi, this is Natalia from ASVAB Success, and in this video, I want to review with you the answers for the Algebra 1 quiz. So, if you're ready, let's get started. We're going to start with the first question. It says 2x plus 7 equals x minus 7. So here it's asking us to solve for x. Remember that to solve for x, what we want to do is we want to get x by itself on one side of the equal sign. So we got to start moving things around. The first thing I want to do is I want to move the x over to this side. And to do that, I have to minus x minus x. So I'm actually going to rewrite this here so it's easier to see it. Okay? So I'm going to minus x minus x. This cancels out. 2x minus x is x. I keep my plus 6 equals. Remember that negative stays there with the 7. So now the x has a 6 added to it. I'm going to subtract the 6 to get rid of it. Whatever I do to one side, I have to do to the other side as well. This leaves me with x equals on this side, and negative 7 minus 6 is negative 13, because when we subtract from a negative number, it becomes more negative. Okay, so our answer here is D. Awesome, I hope this is making sense. Let's take a look at the next one. So the next question here, this is asking us to solve for x and y. This question is when we're solving for two unknowns. Now, based on the way this is set up, it looks like what we can do here is elimination. Remember, when we do substitution, it's because, substitution, ooh, I forgot how to spell that. It's because there's x equals blah, 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 blah. And we can take this and substitute it with what there is here. With elimination, we do that when it has this format. Okay? Here, both x and y are on the same side of the equal sign. So when that happens, we use the process of elimination. Elimination means I want them to look the same in some way so that I can eliminate something. Which sounds funky, but it'll make sense now. Now here, the 2 and the negative 3 plus 2 minus 3, if they have the same number, they could cancel each other out because they're opposite signs. So what I'm going to do is I'm going to treat them like when we do with fractions. I'm going to multiply them by each other. So I'm going to multiply this by 3, which is this number here. And I'm going to multiply this whole thing by 2, which is this number here. And when I do that, they'll become the same. So I have to multiply everything by 3. 3 times 3x is 9x. 3 times positive 2y, positive 6y, equals 3 times 7 is 21. Now the second one. 2 times 2x is 4x. 2 times negative 3y is negative 6y. And 2 times negative 4 is negative 8. Now, these are new equations. If you notice, the 6y and the 6y are the same. They're plus and they're minus. So if we put these two together, these will cancel out. So here, 9x plus 4x is 13x. These cancel out because positive 6 minus 6 is 0. Equals, and then I do 21 minus 8, which gives me 13. So I'm going to rewrite this so it looks nicer. 13x equals 13. The 13 is multiplied to the x, so I'm going to divide. I do it to both sides. And 13 divided by 13 is 1. So x equals positive 1. Now, here it's asking me for both x and y. So I'm going to grab one of my equations again. So let's just use the first one. 3x plus 2y equals 7. And I'm going to plug in x here. I'm going to plug in the 1 because I know what x is now. So 3 times 1 plus 2y equals 7. So 3 times 1 is 3, plus 2y equals 7. I'm going to minus 3. I do it to both sides. This gives me 2y equals 4. And now, because that's multiplied by 2, I divide by 2. And 4 divided by 2 gives me 2. So x equals 1, y equals 2. I'm going to go back to my question. And this is negative 1, positive 2, positive 1, positive 2. Perfect. Our answer is B. Okay, I hope this is making sense. If you're ready, let's keep going. Here we have another question where we are solving for two unknowns. But here, if you notice, this one is different because the x is by itself on one side of the equal sign. Remember in the last one we used elimination because x and y were on the same side of the equal sign for both of them. Here, they're on the same side. Here, they're by themselves. Okay, so what we're going to do instead here is use substitution. This time I do remember how to write it. There we go. So substitution means wherever I see an x in this equation, which is right here, I'm going to substitute with this or replace it. Okay, so I'm going to rewrite this equation. 3 times x. I replace it with 8 minus 6y. Minus 3y equals negative 18. So this is like if I did this. Like that. But it just looks neater. Okay, so before I can simplify this, I do 3 times 8 is 24. And remember, I distribute to everything inside. 3 times negative 6, negative 18y. Minus 3y equals negative 18. So 24. Negative 18 minus 3. Remember, when we're subtracting from a negative, it becomes more negative. So we do negative 21y equals negative 18. So I minus 24, I minus 24. This cancels out. Here, once again, I'm subtracting from a negative number, so it becomes more negative. I'm actually going to add them. 8 plus 4 is 2. 12, carry the 1. This is negative 42. When I divide by negative 21, the negatives cancel out. This cancels out. 42 divided by 21 gives me 2. So y equals 2. Now, it's asking me to solve for both. So I'm actually going to use this equation where it has x equals by itself on one side of the equal sign to solve for x. So x equals 8 minus 6y. X equals 8 minus 6. I replace the y with 2 because I now know what y is, right? Well, let me rewrite this. 6 minus 2 is 12. So x equals 8 minus 12. And 8 minus 12 is negative 4. So my answer here is x equals negative 4, y equals 2. And there it is. Perfect. Okay, I hope this is making sense. Remember, you can always rewatch any part of this video. Let's keep going. So here it says, solve for x, right? 4x minus 8 equals 2x. So we have x on both sides of the equal sign. We want to move it to one side of the equal sign. I'm actually going to subtract 4x here. Okay? This is negative 8 on this side, and 2 minus 4x gives me negative 2x. I'm going to divide by negative 2. I do it to both sides. This cancels out. Negative 8 divided by negative 2. This becomes positive. 8 divided by 2 gives me 4. So my answer here is x equals 4. All right, let's go ahead and do this question together. So it says, what is 8b minus ab plus 7a subtracted from 3a plus 9ab plus b? So what's tricky here is this part, subtracted from. This means that we are taking this away from this. So even though this one is first in the question, this one will go first. So it'll be 3a plus 9ab plus b minus everything else. Okay? Now, this minus, we treat like a negative 1, and we distribute to everything behind. So let's rewrite this again. Okay, now, negative 1 times, negative 1 times 8b is negative 8b. Negative 1 times negative ab is positive ab. And negative 1 times positive 7a is negative 7a. So essentially what it did is it changed the signs, okay? So now that we have that together, now we can combine like terms. So 3a mixes together with negative 7a. So 3 minus 7, negative 4. Then we have positive 9ab, which mixes together with positive ab. So 9 plus 1, positive 10ab. And then finally, positive b minus 8. 1 minus 8 gives me negative 7b. So the answer here is negative 4a plus 10ab minus 7b. And there we are. Our answer is A. Okay, I hope this is making sense. Let's go ahead and take a look at the next one. So this question says, simplify. This is what we call an algebraic fraction or just dividing with algebra, right? Remember what we do here is we subtract the exponents. Okay, so I'm going to rewrite it so it's a little easier to see. And z to the 4th. Okay, so here 2 minus 1 gives me positive 1, so it stays on top. Y doesn't have anything to cancel with, so that stays on the top as well. And then z has 2 minus 4, which is negative 2, so that goes on the bottom as z squared. Remember, whenever we have a negative, that means the bottom one, and they keep the variable with its exponent. So our answer here is xy over z squared, which is c. Okay, I hope that's making sense. Let's take a look at the next question. In this next question, we are once again solving for x. Remember, we want to get x on one side of the equal sign by itself, so step number 1 is to move x. I'm going to move it to this side. This cancels out. 7x minus 3x is 4x. Minus 6 equals, we keep the negative 10, right? Then, that 4x has the 6, so I'm going to do the opposite. I'm going to do plus 6. This cancels out. I do it to both sides. Negative 10 plus 6 is negative 4. Now I'm going to divide by 4 because I want to get rid of this. And 4 divided by 4 is 1. We keep the negative. So our answer here is x equals negative 1. All right, it's looking good, guys. Let's keep going. Okay, so this question is actually really interesting because it doesn't have a sign here. So it says simplify x plus 2, parentheses, x plus 8. So because there's nothing between the 2 and the parentheses, we actually multiply. So we distribute to everything inside. So we leave our x plus, and then let's multiply to everything inside. 2 times x is 2x. 2 times 8 is 16. So this is x plus 2x plus 16. Okay, now x plus 2x, we combine them, and we get 3x, and our 16 stays the same. So our final answer is 3x plus 16, or B. All right, great job. Let's keep going. So here, once again, we have an algebraic fraction, and we're dividing with variables, right? What we want to do, this one's pretty easy to see, so I'm not going to rewrite it. What we want to do here is subtract the exponents. 2 minus 1 gives me positive 1, so it stays on top. And there's nothing to cancel out the b, so it also stays on top. So it's just AB. So our answer here is B. All right, let's do it. Great job. Okay, next question. This says, if A equals 6 and B equals 5, what is the value of A squared minus B squared squared? So here, all we have to do is plug in the numbers into the letters. So because A equals 6, wherever we see A, we replace it with a 6. So this is 6 squared. And because B equals 5, wherever I see the B, I replace it with 5 squared. So A squared minus B squared is 6 squared minus 5 squared, and let's not forget the square here. So now let's simplify this. 6 squared is 36, minus 5 squared is 25. Remember, a squared number just means multiply by itself. So this is 6 times 6, and this is 5 times 5. Okay, 36 minus 25 gives me 11. Let me show you real quick here on the side. There we go. And we keep the square. So now 11 squared gives me 121. All right, and that was it. If you're ready, let's keep going. Next question, it says, solve for x. Once again, we're moving things around. We want to get x by itself on one side of the equal sign. So I'm going to rewrite it up here so it's just easier to work with. Okay, I'm going to move this to this side. This cancels out. X minus 8x is negative 7x. Negative 15 minus 6. I'm going to plus 15, negative 7x equals, this cancels out. Negative x plus 15 gives me positive 9. I divide by negative 7. I do it to both sides. So that can cancel out there. And then I have to do 9 divided by negative 7. So yeah, let me just do that over here. I'm going to just ignore the sign for a little bit, just do the division, and then add the negative afterwards, okay? So 7 goes into 9 one time, 9 minus 7. We add a decimal, bring down a 0. 7 goes into 22 times, 14. Add another 0. 7 goes into 68 times. Okay, I think the answer is clear here, 1.28. But remember, we have to add our negative. So it's negative 1.28. Okay, awesome. Let's keep going. And that's it. Wow, that went very fast. Okay, so that's it for the Algebra 1 quiz. If you have any questions, please feel free to leave a comment below. I hope this made sense to you. And if it's still not making sense, that's okay. Come into one of our Zoom classes and we'll be more than happy to review this with you. Welcome back. So in this lesson, we're going to talk about the next level of algebra. So we started off in the last lesson with easier concepts, like the basic stuff, and now I want to show you more challenging concepts that will help you prepare for those more challenging questions in the mathematics knowledge section, okay? So the first thing we want to start off with is solving for two unknowns. So we looked at solving for one unknown, and the goal with one unknown was simply to get the variable, the unknown, the x, whatever it is, by itself on one side of the equal sign. So when we're solving for two unknowns, usually we will have two equations. So we want to basically isolate one of them, or basically get rid of one of them, okay? So that we can just solve for the first unknown and use that information to solve for the second unknown. So it's going to sound a little weird, me just explaining it like that. So let's go ahead and look at an example. So in this first one, what we can do is two approaches. We have substitution, okay? And we also have combining. When we combine them, okay, when we combine the two equations, what we can do is we can kind of manipulate one of them so that if I combine it either by adding or subtracting it, then essentially one of the variables will cancel out. So what does that look like? Okay, first of all, I want to look to see if there's anything I can cancel out. Like if I add 2x plus x, will that cancel out? No, that gives me 3x. If I subtract 2x minus x, will that cancel out? No, that just gives me x. If I add y plus y, will that cancel out? No, that gives me 2y. But if I subtract and I say y minus y, will that cancel out? Yes, it actually does. Okay, so let me do that then. I'm going to multiply the second equation, the entire thing, by negative 1. Okay, and I'm going to rewrite it. So this becomes negative x minus y equals negative 4. So now that I've done that, I'm going to cross this out. Okay, and now I'm going to combine these two equations. And I'm just going to add them or, do an operation. So I start with 2x. 2x minus x gives me x because 2 minus 1 is 1. Y minus y gives me 0. So that just cancels out. Equal sign is carried down. 5 minus 4 is 1. X equals 1. So by eliminating, okay, or combining, it could also be called elimination. By eliminating or combining, I got rid of one of the variables, and now I have one variable left, and it just tells me that x equals 1. Okay, so now I know that x is 1. I still have my two original equations, and I still want to know what y is, okay? So let me have to solve for y. So I'm going to use the second equation, x plus y equals 4. Okay, remember this one right here before I transformed it? So now that I have x, I'm going to replace it right here. I'm going to substitute it. So wherever I see an x, I'm going to substitute it with 1 because I now know what x is. So 1 plus y equals 4. I subtract because I want to get the y by itself on one side of the equal sign, and that 1 is added to the y, so I'm going to subtract. And whatever I do on one side of the equal sign, I also have to do to the other. This cancels out, and I'm left with the y by itself on this side, and 4 minus 1 is 3. So x equals 1, y equals 3. And that's it. That's my answer. Okay, so we do this with the process of elimination, or combining. So let's go ahead and try something that's a little more difficult. So here we see x and 3x, negative 3y, negative 4y. So neither one of these, I can't do x minus 3x, that's not going to cancel out. I can do 3y minus 4y, that won't work, okay? But what I can do is if I multiply this x by negative 3, this will become a negative 3x, and this will be a 3x. And negative 3x plus 3x is 0. So that means that what I want to do is I want to multiply the whole first equation by -3. So for me, this reminds me a lot of when we're adding and subtracting with fractions, and we have to multiply stuff to be able to get the same denominator. It's kind of the same idea. We're just trying to figure out what do I multiply one of these by to be able to like eliminate things and then be able to solve. Okay, so now that I did this, I end up with, I distribute everything. -3 times x is -3x. -3 times -3y is positive 9y. And -3 times -2 is positive 6. And then I'm going to rewrite the second equation underneath this so that it's just easy for me to see this. So now -3x plus 3x cancels out. That just gives me 0. Okay? And 9y minus 4y is 5y, because 9 minus 4 is positive 5. And here, 6 plus 4 is 10. Okay? Essentially what we're doing is it's like we're adding. And when we add, if this is a negative, it remains negative. Like it's still 9 minus 4. Okay? And then if it's positive, it's 6 plus 4. So we're using the sign that's in front of the number. Positive 3x, negative 4y, positive 4. All right, so now that I have 5y equals 10, that 5 is multiplied to the y, so I'm going to divide by 5 to solve for y to get it by itself, and I get y equals 2. Okay, now that I've solved for y, I go back to my original equation. And I'm going to use the first one, x minus 3y equals -2. But now I know what y is, so I'm going to substitute. Wherever I see a y, I'm going to replace it with 2. So I'm going to rewrite this, x minus 3y, but that's actually times 2, equals -2. You see how I replaced the y with a 2? Okay, so now I'm going to multiply. X minus 6 equals -2. I got that because -3 times 2 is -6. And this this 6 is being subtracted from the x, so to get rid of it, I'm going to add 6. I'm doing the opposite. X equals -2 plus 6 is positive 4. So y equals 2, x equals positive 4. Okay? All right, so now let's take a look at another concept. So when we have something like x squared plus 3x plus 5, for example, this is called a quadratic equation. It's called a quadratic equation because there's an x to the square to the second power, okay? If it was y squared plus 3y plus 5, it would still be a quadratic equation. What makes it quadratic is this variable right here, okay? Now, we get to this quadratic equation by doing something called foiling. And foiling is when we multiply this right here, okay? And FOIL actually stands for the process or the order in which we multiply. So it stands for first, outer, inner, and last, okay? So if we were to do, before we do this one, let's do just kind of like a random example. Let's say we're doing x plus 1, x plus 6, okay? We do the first times the first. X times x is x squared. We do the outer, x times 6, positive 6, so it's positive 6x. Now we do the inner, positive 1 times x is positive x. And now the last, positive 1 times positive 6, 1 times 6 is just 6. So now that I've done that, I'm going to look at this and say, well, are there like terms? Can I combine anything? Remember in our last lesson, combining like terms? This is where we use it. Plus 6x plus x, 6 plus 1 is 7. So this becomes x squared plus 7x plus 6. And that's my answer. So this is the process of FOILing, okay? So now that we've done that, let's look at this example over here. X plus 3 times x plus 4. So we do the first, x times x, x squared. We do the outer, x times positive 4, positive 4x. We do inner, positive 3 times x, positive 3x. And we do last, positive 3 times positive 4 is positive 12. We combine like terms, so we add up these two, we get x squared plus 7x plus 12. And there we go. Okay, so let's look at some practice. Yeah, let's start with this one. Okay, I'm going to go ahead and give you a chance to try this one. Even if you get it wrong, that's okay. I still want you to give it a try. So if you want, pause the video at this moment, and when you're ready, just hit play and I'll go over it with you, okay? All right, here we go. So remember, it's FOIL. I'm going to write it here so we can remember. First times the first, 3x times x is 3x squared. Outer times the outer, 3x times 1 is just positive 3x. Inner times inner, positive 2 times x is positive 2x. And last, positive 2 times positive 1, positive 2. So now we combine these two, we add them up. They have the same variable, the same exponent, so we can add them together. So we get 3x squared, 3x plus 2x is 5x plus 2. And there we go. Okay, let's look at the next example. So here we're already working with a -5 or -5. So make sure you pay attention to that as you're foiling this out. So if you want to give this a try, go ahead and hit pause on the video and give it a try. And when you've already given it a try and you're ready to look over it, come back, just hit play, and you'll see the explanation. Okay, here we go. So first one, x times x is x squared. Outer, x times positive 1 is positive x. Inner, -5 times x is -5x. And last, -5 times positive 1 is -5. So now we combine these like terms. 1 minus 5 gives me -4. So that's -4x minus 5. Something very important that confuses people, just because there's a negative behind this x does not mean that negative belongs to x. The sign in front of a number or in front of a variable is the one that belongs to it. So if there's nothing in front of this x, that means it's a positive x, okay? And this negative belongs to the 5. So I hope that distinction helps. Okay, so here, let's try another one. This gets a little more difficult. I'm going to give you a hint. You're going to FOIL these two first, and then after you FOIL it, you go ahead and multiply the whole thing by 2. But don't forget to multiply by 2 because that's where people make a mistake, okay? So if you want, go ahead and hit pause now, give this a try, and when you're ready, come back to watch the explanation. Okay, here we go. So let's get started. First times first, 2x times x is 2x squared. Outer, 2x times -7 is -14x. Inner, positive 1 times x is positive x. And last, positive 1 times -7 is -7. So I'm still going to put this whole thing in parentheses and put a 2 up here so I don't forget to multiply. So now in here, I can combine like terms. -14 plus 1 is -13. So I'm going to do 2x squared minus 13x minus 7. So now I'm ready to multiply by 2. So I distribute this to everything. So 2 times 2x squared, 4x squared, 2 times negative 13x is negative 26x, and 2 times negative 7 is negative 14. Because this is a positive 2, it does not change the signs. It still stays the same. Positive, negative, and negative. Okay? All right, awesome. I hope you got that. Let's go ahead and keep going. So sometimes when we're working with quadratics and foiling, we have something called a special situation like a difference of square. A difference of square is something like x plus 4, x minus 4. So if you notice, we have the same variable first, the same number second, and it's a plus and a minus. Okay, so they're different signs. When we foil this, we can look at how it foils. I'm going to foil it normal. X times x is x squared. Positive 4, outer. X times negative 4 is negative 4x. Inner, positive 4 times x is positive 4x. And last, positive 4 times negative 4 is negative 16. What happens here is that negative 4 plus 4 actually cancels out, and the answer becomes x squared minus 16. So sometimes people like to memorize x plus 4, x minus 4 gives me the square of the first one minus the square of the second one. Okay? So that's just something to kind of keep in mind. So before we move on, let's look at another example of that. So x plus 2, x minus 2, I see that it has the same first variable, the same number, and the signs are different. Okay, so this is difference of squares. So x squared minus 4. I square the first one minus I square the second one, and that gives me the answer. Okay? Let's look at one more example, and I want you to give it a try. Okay, so you can hit pause now, and you can give it a try. When you're ready, just hit play, and I'll go over it with you. Okay, here we go. So this one would be the square of the first one minus the square of the second one. Now, I will say this. I'm just showing this to you because sometimes it could come up as a question. But if you prefer to foil it out completely and just take that extra step to make sure you get it right, that is completely okay. And it's actually encouraged. But if you ever see something that says difference of squares, then now you know what it means. And that's what matters. Okay? All right. So let's look at the next step in this, which is factoring quadratics. So quadratic equations, remember, are ones that have this right here, our famous square on the variable. And there's nothing higher than that as an exponent. The square is the highest exponent. Okay, so let's say it's like 2x plus 2. Okay, now the same way that something multiplies to become this, the way we did here, so I'm going to take you back real quick, with the foiling, we can go backwards. We can go the other way to go from this to something with parentheses. Okay, so let's say in this one, this would be x plus 1, or x plus 1 squared. Okay, now how do we do that? How do we know that? Well, that's what I'm going to show you now. Step number 1, you want to, so I'm going to put this in steps for you. Okay, step number 1, you want to list the factors for the third component of your quadratic. Okay, so list the factors. Remember, the factors are the numbers that multiply to equal that number. Okay, they multiply and the product will be the third number. The second step would be to choose the factors that add or subtract to equal the second number. Okay, which would be this one right here. For example, the factors of 1 are 1 times 1. Okay, but we also have to think of negatives. Negative 1 times negative 1 gives me positive 1, right? So which one of these adds up to 2? I need it to add up to 2. So 1 plus 1 gives me 2. Perfect. Negative 1 minus 1 gives me negative 2. That's not what I'm looking for. So this is what I use. And then I assemble it into my parentheses. Okay, so that might be a little confusing the way I explained it, but I hope now that when we do some practice, it'll kind of come together for you a little bit better. Okay, so first one, factors of 56. Okay, let's see. 56, 7 times 8 equals 56, and 4 times 14 equals 56, and 2 times 28 equals 56. And it's positive. I could do negative 7 times negative 8, negative 4 times negative 14, and negative 2 times negative 28. Remember that a negative times a negative equals a positive. So that's why I can consider those. Now I'm looking for something, that was step 1. Step 2 is I'm looking for something that adds up to give me positive 15. So immediately I can eliminate these negatives because they're going to give me a negative. So here we go. 7 plus 8 gives me positive 15. So we found our winner. 4 plus 14 gives me 24. Sorry, not 24, 28. And 2 plus 28 gives me 30. So I'm going to set up my equation now. X plus 7, I use the first one. And the second one is going to be x plus 8. And that's it. Okay? Let's go ahead and try another example. So this one has negatives, so it's going to be a little more complicated. Let's find the factors. 12 is 1 times 12, 2 times 6, 3 times 4. But this is negative. How do we multiply to get a negative? A negative times a positive gives me a negative. So I'm going to do negative 1 times positive 12 and positive 1 times negative 12. Negative 2 times positive 6 and 2 times negative 6. Negative 3 times positive 4 and 3 times negative 4. Okay? All of these scenarios will give me negative 12. So now I have to find which one adds up to give me negative 1. So negative 1 plus 12 gives me positive 11. That's not good. 1 plus negative 12 gives me negative 11. That's not good. Negative 2 plus 6 gives me positive 4. That's not good. 2 minus 6 gives me negative 4. That's not good. Negative 3 plus 4 gives me positive 1. That's not good. And 3 minus 4 gives me negative 1. That's exactly what I'm looking for. So now I'm going to set up my parentheses, and I'm going to fill it in with these two. Positive 3, negative 4. And that is my answer. Okay? All right, so now that we've gone over 2 of them, I want you to give it a try on your own. So I encourage you to pause the video at this point, give this one a try, and get as far as you can. Even if you can't get all the way to the answer, that is okay. Just get as far as you can. And when you're ready, just hit play again to watch the explanation. So with this one, we're going to do our first step. We're going to find the factors of 18. 1 times 18, this is positive, so it could be negative 1, negative 18 also. 2 times 9, or negative 2 times negative 9. 3 times 6, or negative 3 times negative 6. And that's it. We can't do 4. Okay, so now we want it to add up to negative 11. So let's go ahead and see which one does. 1 plus 18, 19. Negative 1 minus negative 18, negative 19. 2 plus 9, positive 11. Negative 2 minus 9, negative 11. And there it is. So now I set up my two parentheses, x, and I'm going to put these in here, x minus 2 and x minus 9. Okay? I hope you got it. All right. So let's do another example. Go ahead and hit pause. Give this one a try. When you're ready, just come back and I'll go over it with you. Okay, here we go. So let's look at the factors of 21. And this is a negative 21. So we have negative 1 times positive 21, or positive 1 times negative 21. Negative 3 times positive 7, or positive 3 times negative 7. And that's basically it, right? There's not much that multiplies to equal 21. Okay, so now let's figure out which one gives me positive 4, because that's what we want. We want it to add up to positive 4. So negative 1 plus 21, that's not going to work. And 1 minus 21 is also not going to work. That gives me positive 20 and negative 20. So negative 3 plus 7 gives me positive 4. That's what I'm looking for. 3 minus 7 gives me negative 4. That's not what I'm looking for. So I set up my two parentheses, and I fill in the information. Minus 3 plus 7. And that's it. I'm done. Okay, here we go with another example. Go ahead and give this one a try. Just hit pause. When you're ready, just come back and watch the explanation. Alrighty, so this one's pretty easy. It's all positive. So 36, we have a lot of factors to work with. 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. Alright, so 1 plus 36 gives me 37. 2 plus 18 gives me 20. 3 plus 12 gives me 15. There it is. So we do x and x plus 3 plus 12. And there we go. Okay, I hope you got that one. Alright guys, so that's basically it for the more challenging aspects of the algebra questions you might come across in the mathematics knowledge. You're going to get some more challenging questions in later modules, but for the time being, this is the next step. Please make sure that you give that test underneath this video a try, and if you miss any of the questions, just go over it, and feel free to post a comment if you have any question at all. Remember, we have our sessions every single week, so if you want to join in on a session and work on this even further, then you're more than welcome to do so. Alright, good luck! Algebra Success, and in this video I want to review with you the Algebra Level 2 quiz. So if you're ready, let's get started. First of all, this question here asks us to factor. Here we have what looks like FOILing. Remember, that's first, outer, inner, last. So essentially what we're going to do is we're going to multiply what's inside these two parentheses to each other. First, a squared times a squared. When we multiply variables with exponents, we add the exponents. So a squared times a squared is a to the fourth. So that's first. Outer, a squared times b squared. Positive a squared b squared. We just put them together. That's all it is. Okay, then inner, negative b squared times a squared is negative a squared b squared. We put in alphabetical order, a comes before b. And then finally it's last. Negative b squared times positive b squared gives me negative b to the fourth. So last step is to combine like terms. A squared b squared, a squared b squared. This is plus 1 minus 1. That cancels out, and we're left with a to the fourth minus b to the fourth. So our answer here is D. Okay, perfect. Let's keep going. So once again, we're FOILing, right? First, outer, inner, last. So first one, 2x times x squared is 2x to the third. Outer, 2x times negative 5, negative 10x. Inner, 7 times x squared, positive 7x squared. And last, 7 times negative 5, negative 35. So my answer here, there's nothing I can combine because this is just like a regular x. This is an x squared. So I'm going to put them in order. 2x to the third, 7x squared comes next, negative 10x minus 35. Why did I switch and put the plus 7x squared first before the 10x? Because the exponent here is larger. So that's why it goes in that order. So my answer here is A. 2x to the third, plus 7, minus 10, minus 35. Always check the signs because it's really easy to mess that up. For example, here, this one says 2x to the third, but it's minus 7x. So be really careful with the signs, okay? All right, let's keep going. What is the result of x plus 9 times 2x minus 1? We're FOILing again. X times 2x is 2x squared. X times negative 1 is negative x. 9 times 2x is positive 18x. And last, 9 times negative 1 is negative 9. Here we do have like terms, so 2x squared stays the same. There we go. Negative x plus 18x is plus 17x, negative 9. So 2x squared plus 17x minus 9, our answer is C. And if you notice, the only difference between C and D is that negative in the 17 or the positive in the 17. So once again, pay attention to the signs, okay? All right, let's keep going. Here we go. So here we're FOILing, and we also have a 3 on the outside. So I want to multiply the 3 first to everything inside. Actually, no, let's FOIL first. So x times x is x squared. X times positive 9, positive 9x. Negative 3 times x, negative 3x. And negative 3 times positive 9, negative 27. So here, positive 9 minus 3 is combining like terms. I keep bringing down the 3 so I don't forget to multiply it, okay? So x squared, 9 minus 3 is positive 6x minus 27. So now I have to distribute that 3 to everything inside. So 3 times x squared is 3x squared. 3 times positive 6 is positive 18x. And 3 times negative 27 is negative 81. So it's not this, it's not this. 3x squared, positive 18, negative 81. Perfect. C is it. All right, next question. So this one is similar to the last one. We're going to wait to distribute that negative 2 to the end. We start with the FOILing. But we still write our negative 2 so we don't forget it, okay? X times x, x squared. X times positive 8, positive 8x. Negative 6 times x, negative 6x. Negative 6 times 8, negative 48. And now we're going to distribute. Oh, actually, sorry, combine like terms. So x squared, 8x minus 6x is positive 2x. and then minus 48. Now we can distribute. Negative 2 times x squared is negative 2x squared. Negative 2 times positive 2x is negative 4x. And negative 2 times negative 48 is positive 96. So negative 2x squared minus 4x, positive 96. And our answer here is B. Okay, next question. So here, we're holding an a squared on the outside, so I'm going to write it here so I can distribute it later. So a times 3a is 3a squared. A times 5 is positive 5a. Negative 2 times 3a, negative 6a. And then negative 2 times positive 5 is negative 10. I'm going to combine like terms. I bring down the a squared along with it. 3a squared. Okay, 5 minus 6 gives me negative 1, so it's negative a minus 10. Now we get to distribute the a squared. A squared times 3a squared is 3a to the 4th. A squared minus a, negative a to the 3rd. And a squared times negative 10 is negative 10a squared. Okay, so here 3a to the 4th, negative a to the 3rd, minus 10a squared. We just double check to make sure everything's correct. And that's it. So it's always good to slow down and pay attention because you might have done everything right and then you accidentally pick the wrong number because you rushed. Or you pick the wrong answer because you rushed when you were looking at them. So be aware of that. Don't let that happen to you. Okay, next question. So here, we're doing a negative and an a squared. We're going to distribute that at the end. So we're going to keep foiling it as usual. 3a times a, oops, sorry, I forgot to write the negative and the a squared. Negative a squared. I'm going to bring them together so it's just easier to see them, okay? All right, so 3a times a, 3a squared. 3a times 5, positive 15a. 7 times a, positive 7a. And 7 times 5 is positive 35. We're going to combine like terms. 15 plus 7 is 22, so this is negative a squared. There we go. 3a squared plus 22a plus 35. Okay, now we can distribute. Negative a squared times 3a squared is negative 3a to the 4th. Negative a squared times 22a gives me negative 22a to the 3rd. That kind of looks like a 9. Sorry. A to the 3rd. There we go. And now negative a squared times 35 is negative 35a squared. So we're looking for negative 3a to the 4th, negative 22a to the 3rd, negative 35a squared. Our answer here is D. Okay, awesome. Let's keep going. So this one, we have to square what's in here, FOIL what's over here, and then multiply them to each other. So let me square this. Negative x times negative x. Negative times negative is positive, and x times x is x squared. So it's positive x squared. So now that I've done that, I'm going to keep that up here to distribute after I FOIL. X plus 1, x minus 1. Okay, so x times x, x squared. Let me keep my x squared up here. Okay, x times negative 1, negative x. Positive 1 times x, positive x. Positive 1 times negative 1, negative 1. So here I can combine these two. They are the same. They cancel out, and I'm left with x squared on the outside, and then x squared minus 1 on the inside. Now I'm going to distribute x times x squared times x squared, sorry, is x to the 4th. X squared times negative 1 is negative x squared. So here, let me make space because you can't see it. Our answer is B. And that's it. All right, let's look at another one. So here, same thing. We're going to wait to distribute this one. Let me write 4x here. Okay, x times x, x squared. X times 9, positive 9x. Negative 1 times x, negative x. Negative 1 times positive 9, negative 9. Positive 9 minus x. Let me bring everything down. 9 minus 1 is positive 8. And I keep my minus 9. Now that I've done that, I distribute everything. 4x times x squared is 4x to the 3rd. 4x times positive 8x is positive 32x squared. And then 4x minus 9 is negative 36x. So it looks like it's this one. 4x to the 3rd, positive 32x squared, minus 36. Our answer here is B. Okay, I hope you're getting this. Here's our final question. We hold this one to the end, right? N squared times n, let's hold it out here. N squared times n is n to the 3rd. N squared times 7 is positive 7n squared. Negative 1 times n is negative n. And negative 1 times 7 is negative 7. Here, I can't combine anything. This is 3, 2, 1 with the exponents. So now I'm just going to distribute. N times n to the 3rd is n to the 4th. N times positive n squared is positive 7n to the 3rd. N times negative n is negative n squared. And finally, n times negative 7 is negative 7n. So this is n to the 3rd, this is n to the 3rd. N to the 4th, positive 7 minus n squared minus 7n. My answer here is B. Okay, was that it? Is there another one? Oh, that's it. Okay. If you have any questions, please feel free to let us know in the comments below. And if you're still stuck on this, remember you can always come into Zoom class and let us know, and we're happy to help you. All right, keep up the great work. Hey, this is Natalia from ASVAB Success, and in this video, I want to discuss with you linear equations. So linear equations is a really big subject, and there's a lot that we can talk about, but I want to talk to you about specifically the questions that tend to come up on the ASVAB, so I'm basically going to focus on that information. So the first kind of question that comes up having to do with linear equations on the ASVAB has to do with slope. So the first thing I want you to learn is the slope formula. So slope is always represented by the lowercase letter m, and the equation to find slope is y2 minus y1 over x2 minus x1. This is the equation that you want to memorize. All right, or the formula you want to memorize. Now, what does this mean? When we find a slope, what we're doing is we're finding
the 2 points, and we're finding the slope between the 2 points. So let's say we have a line that goes like this. So this is the y coordinate, this is the x coordinate, and this is our line right here, okay? The slope is the inclination of this line, and it is determined by how much the y changes over how much the x changes. So when we're given our 2 points, we have x1, y1, and x2, comma, y2. That's the format that the points are given to us in. So what we do is when we're given our numbers, we take them and we plug them into our formula and we find the slope, right? So what does that look like? It's very easy. Let's say our 2 points are -3, comma 2, and 5, comma 6. So these are our 2 points, our 2 sets of points. We're going to label them x1, y1, x2, y2. And we do that so that it's easy to put things in the right place and we don't get lost. So now we're going to plug stuff into our equation. M equals, or the slope equals, y2 is 6 minus y1 is 2. Now over x2, that's 5, minus x1, -3. Okay, so now we're going to go ahead and simplify this. 6 minus 2 gives me 4. 5 minus -3. Well, when we subtract a negative number, they become positive. It's like the negatives cancel each other out, right? So this becomes 5 plus 3, which is 8. I can simplify this by dividing by 4, top and bottom, because it is a fraction I can simplify. And I'm left with 1/2. So the slope of the line between these 2 points is positive 1/2. A slope can be positive, a slope can be negative. As long as it's simplified, the sign is okay. So in a question on the outside, you can be given 2 points and ask the slope of the line. Let's see what that looks like, all right? So here it says, find the slope of points 3, 1, and -3, 4. If you want to pause here and give it a try yourself, you're more than welcome to. If you want to go ahead and see the explanation, then let's keep going. Step 1 is we label our stuff. So x1, y1, x2, y2. We write our formula, y2 minus y1 over x2 minus x1. So now I'm going to go ahead and start plugging stuff in. So y2 is 4, y1 is 1. x2 is -3, x1 is 3. So now we subtract. 4 minus 1 is 3, and -3 minus 3 gives me -6. So I'm going to simplify this by dividing by 3, top and bottom. I get 3 divided by 3 is 1. -6 divided by 3 is -2. So this is -1/2. All right? Okay, awesome. I hope you got this. I hope this makes sense. If not, feel free to go back, take a look at it again. All right? So we have, oops, let me zoom out a little bit so you can see the question. We have another example here. This is just the same thing. It's just worded a little bit differently, okay? So this one says the coordinates of points A and B are -1, 5, and 8, 2, respectively. Basically, they're saying these are the 2 points. What is the slope of the line that connects the 2 points? So we're just finding the slope. That's all this means. We're going to label x1, y1, x2, y2. And we're going to write our equation. y2 minus y1 over x2 minus x1. So m equals y2 is 2, y1 is 5. x2 is 8 minus x1, which is -1. So 2 minus 5 gives me -3. 8 minus -1, these become a positive, and I get 8 plus 1 is 9. I'm going to divide by 3, top and bottom, to simplify this, and I get -1 over 3, or -1/3. And that is the slope. Okay, I hope you got this. Let's take a look at the next concept. So slope-intercept form refers to a specific way of writing a linear equation. A linear equation has both x and y, and no exponents, okay? If it has exponents, it's not linear. So when we say slope-intercept form, it's because it's written as y equals mx plus b. M is a number, and b is a number, and y and x stay just like that. M is referring to the slope, like we learned a little bit earlier, and b is referring to the x-intercept. We're not going to worry about that right now. What matters here is this, the slope. If we're given y equals -2x plus 5, and it's asking us what is the slope of this, all we have to do is look at the number that's multiplied to the x, and equals -2. That is our slope. So it's really easy. You just have to know the information, okay? So whenever we see a line like this, we know that the slope is whatever is multiplied to the x, whatever number is multiplied to the x. Now, what happens if you get something that looks like this? This is not slope-intercept form. Why? Because in slope-intercept form, sorry, I have a mess here. In slope-intercept form, the y is by itself on one side of the equation. Here, it is not by itself. It has a 5x added to it. So to be able to find the slope of this, what we need to do is we need to get the y by itself. So we just subtract 5x. We do it to both sides. So this cancels out. And I get y equals -5x minus 3. Why -5x minus 3? Because the 3 does not have an x, so they cannot be combined. They're not like terms, okay? So now that I have -5x minus 3, what is the slope? The slope is whatever is multiplied to the x. So here the slope is -5. And that's it. So all we need to know here is if we're given an equation and they're asking us for the slope, what we want to do is put it in this format where the y is by itself on one side of the equal sign, and then whatever is multiplied to the x, that will be our slope, okay? All right, so there's one more concept that I want to tell you about. a very common question on the ASVAB is asking which line is a linear equation. So a linear equation has to be a line that has an x with no exponent. So this is a linear equation. This is a linear equation. This is a linear equation. This is not a linear equation. This is not a linear equation. Why? Because in these, the x has an exponent. So if you ever come across a question that asks you which of these is not a linear equation, you look for the one that has an exponent, okay? If you come across something like this, when you simplify that, when you factor it out, what you're going to get is an x that has an exponent, which means that this is not a linear equation either, okay? So if you have to do the extra step of simplifying or factoring something, that is okay. Just make sure that you choose something that does not have an exponent if it's asking you for a linear equation, okay? All right, believe it or not, that is it. This is a short subject. It's just a couple of different kinds of questions that have been popping up on the ASVAB recently. I want to make sure that you're ready for them, okay? If you have any questions, please feel free to leave a comment below. And there is a quiz below to help you go ahead and practice what you've learned. All right, good luck. Keep studying. Hi, this is Natalia from ASVAB Success, and in this video, I want to review with you some linear equations. Well, these are the questions from the linear equation quiz. So if you're ready, let's get started. Now, in this lesson, you learned a couple of different equations, right? And when I say equations, what I mean is formulas. You learned the slope formula, which is m equals y2 minus y1 over x2 minus x1, okay? Now, this question says, the coordinates of point A and B are, this is a line, 2, 4, and -2, -4, respectively. What is the slope of the line that connects the 2 points? So here's telling us this is a line, these are the points, what's the slope? Well, we plug it into this super awesome equation that we have here. So first things first, let's label x, y, x, y. This is x1, y1, x2, y2. If you wanted to make the other one x1, that's fine. It doesn't matter as long as both of them are the same number, okay? So now let's plug stuff into our equation. M equals y2 is -4 minus y1 is +4. So even though it's +4, the equation has a minus, so that's why we keep it. Then x2, -2 minus x1, +2. Okay, there we go. So now -4 minus 4 gives me -8 over -2 minus 2 gives me -4. These cancel each other out. I'm left with 8 over 4, and 8 divided by 4 is just 2. So my answer here is 2. All right, I hope this is making sense. Let's keep going. Oh, the format changes a little bit. Okay, so something else that you learned in this lesson is that when we have the equation of a line, it doesn't have any exponents on the x. The x is just x, there's no exponent. So here it says, graphs of the following equations are straight lines except. So this one has no exponent. This one has an exponent. No exponent, no exponent. I'm not talking about the y. I know this one looks like I underlined the y. I'm talking about the x. The x does not have an exponent on these three, but it does on this one. So that tells us that that is not a straight line. In reality, that one is an equation for a parabola, which is a different kind of graph altogether. Okay? So that's how we answer that question. Okay, let's keep going. Next question says, the coordinates of points A and B are 1, 7, and -3, 5, -5 respectively. What is the slope of the line that connects the 2 points? So we're going to use our equation again, m equals y2 minus y1 over x2 minus x1. Or we're going to label stuff, right? So xy, xy, this is 1, this is 2. Now let's plug stuff into our equation. y2 is -5 minus y1 is 7. x2 is -3 minus 1. And there we go. Okay, so now let's go ahead and simplify this. -5 minus 7 gives me -12. -3 minus 1 gives me -4. These cancel out, and I'm left with 12 over 4. And 12 divided by 4 gives me +3. And that's our answer. Okay? All right, let's keep going. Next question. It says, in the line y equals -4x plus 9, what is the slope? So if you remember from the lesson, I told you that the slope, whenever we have our equation set up in this specific format, y equals mx plus b, where y is by itself on one side of the equal sign, x is multiplied to a number, and then it's either added or subtracted with another number. B represents some number. When this is the case, and it's in this format, m is our slope. Here, the format is y equals -4x plus 9. So it's in the same format, the y, the x, and the 9. Okay, so that means that -4 is our slope. And that's it, that's our answer. It's just a matter of recognizing the different formats. Okay, next question says, the coordinates of point A and B are -1, 3, and 0, -4, respectively. What is the slope of the line that connects the 2 points? So here, once again, we use our slope equation, m equals y2 minus y1 over x2 minus x1. So let's label and then plug stuff in. So x1, y1, x2, y2. So let's start plugging stuff into our equation. y2 is -4 minus y1 is 3. x2 is 0 minus -1. Okay, now here the negative and the negative make a positive. But we still put the minus, and then we put the negative that comes from that number. So now let's not plug stuff in, sorry, let's simplify. -4 minus 3 is -7. 0 plus 1 is +1. This is just -7 over 1, which is -7. And that's our answer. Okay, next question. So this question says, graphs of the following equations are straight lines except. Once again, we're looking for the straight line equations, or the straight line equations are the ones that do not have an exponent, right? The x does not have an exponent. So this one does not have an exponent, that's a straight line. This one has an exponent. This one does not, this one does not. So our answer here is B, because this one has an exponent, so that is not a straight line.
All right, next question. It says, which of the following equations has a line with a negative slope? So here, we're looking at different equations. I'm going to write each of them, and we're going to look at each of them. So this one is not, remember when we're looking at the slope, we want the equation to look like this. The minus 7 is in the way, so I'm going to plus 7. I'm going to do it to both sides, and this gives me plus 2. Now, the slope is the m, right? So here the slope is positive 2. We're looking for a negative slope, so this is not it. Okay, next equation. Y equals negative 5 plus 6x. Well, we want the mx to come first, so the 6x is going to come first, and it's going to go ahead and carry the sign that's in front of it. So this becomes y equals 6x minus 5. The 6 is a slope, it's positive, so this is definitely not it, okay? And then we're going to look at the next one. It says y equals negative 4x plus 8. Here, this is not in the correct format, so what we're going to do is we're going to distribute, okay? Negative 4, negative 8. So y equals negative 4 times x is negative 4x, and negative 4 times positive 8 is negative 32. Now that it's in the y equals mx plus b format, the negative 4 is our actual slope. And it's a negative, and that's exactly what we're looking for, so that is our answer. All right, let's keep going. So graphs of the following equations are straight lines except here, no exponent, no exponent, no exponent. Now this one, you might remember this from our Algebra Level 2 class. This needs to be FOILed. So let's FOIL it. We multiply first times first, x squared. Outer, positive 4x. Inner, positive 3x. And last, positive 12. 4x plus 3x is 7x, positive 12. And we have our y equals. Here, we have an exponent, which tells us that this is not the graph of a straight line. Okay? That's it. I hope this is making sense. Let's keep going. All right, let's do this one. So the coordinates of point A and B are 0, 5 and 2, negative 7, respectively. What is the slope of the line that connects the 2 points? We're going to use our slope formula again. We're going to go ahead and label x1, y1, x2, y2, and we're going to plug stuff in. y2 is negative 7 minus y1 is 5. x2 is 2 minus x1 is 0. Negative 7 minus 5 is negative 12, and 2 minus 0 is 2. Negative 12 divided by 2 is just negative 6. So our slope here is negative 6. Okay, final question. It says, what is the slope of the following line? 3x minus 2y equals 5. So here, remember, when we're dealing with an actual equation of a line, and we want to know the slope, we want it to be in this format. So we can actually move it around so that it is in that format. Right now, it says 3x minus 2y equals 5. So what I want to do is I want to get y by itself on one side of the equal sign like this one. First thing I'm going to move is the 3x. This cancels out and left with negative 2y on this side. I put the negative 3x first, and this is a positive 5, so this is going to be plus 5. Okay? Now, next thing I need to do, this 2 is multiplied. I need to divide it by negative 2. I do it to everything on this side. I could do it over one big one, but I'm going to do it to each one. Y equals negative 3 over 2. This is positive, because it's two negatives, so the negatives cancel each other out. This is 3 over 2, x, minus, because this is positive 5 and negative 2, so minus 5 over 2. Now the point here is the slope. It's whatever is multiplied to the x. So our slope here is 3 over 2. And that's it. All right, I hope this makes sense. Remember, if you have any questions, you can always leave a comment below, or you're welcome to come into Zoom class and let us know. We'll be happy to help you with this. Keep up the great work.